Hello, and welcome to the planet's memory, a place where questions are allowed to echo and science moves at the speed of wonder. Here, we let time stretch and spiral, and follow it not as a line, but as a lingering breath. If you're here tonight, maybe you're looking for stillness. Maybe you're curious about the deep, slow things, the kind of mysteries that don't shout for your attention, but whisper softly through the cracks of the known world. Before we begin, I'd love to know, where are you listening from? Are you wrapped in blankets? Or lying beneath the quiet breath of a ceiling fan? Is the night air cool on your skin? Are there stars outside your window? Or just the hush of curtains and sleep? And if this kind of slow exploration brings you comfort, if the thought of deep time and lost memory feels like a story you've always wanted to hear, then I gently invite you to like, or maybe share this video with someone else who drifts off to questions like these. It helps this little sanctuary of science and wonder grow. And I promise, here, nothing is rushed, nothing is loud, and nothing asks too much of you. So now, let's begin our descent. Not into darkness, not into fear, but into something softer, something older, something Earth might still be trying to remember. What if time is just a story Earth tells us? A comforting story, a linear one, one that says, here is the beginning, here is the middle, and here at last is the end. It's a neat story. It makes us feel anchored. But what if Earth doesn't tell stories that way? What if the planet we live on, this slow-spinning library of silence, never started in the way we imagine, and never plans to end? What if time here doesn't march forward at all, but loops, folds, forgets, and returns? Geologists speak of deep time, time that isn't felt but revealed, layer by layer, in stone, in ice, in isotope. We see it in the zircon crystals older than the moon, in the wave-polished cliffs that remember oceans long vanished, in the way radioactive decay keeps track, quietly, of moments we'll never witness. But even those clocks are built on assumptions, on beginnings we've chosen, on frameworks that fit what we know, or think we know. Could Earth be older than we think? Not just by a few centuries, not by a hidden continent or a forgotten city, but profoundly older, epochs older, stories older than bones, timelines buried so deep, not even memory remembers them. When we date the planet, we use half-lives and meteorites, assuming the clock began when molten rock cooled into crust. But what if that wasn't the first clock? What if there were versions of Earth before this one? Not parallel Earths in space, but earlier drafts of this same world, overwritten by lava, erosion, and time's indifference. The surface of our world is not a fixed skin. It moves, melts, and remakes itself. Entire ocean floors disappear beneath continents, pulled into the mantle in slow, grinding silence. These are not just geological events. They are acts of forgetting. The planet loses pieces of itself over and over again, not because it wants to, not because it chooses to, but because that's what living things do. They shed, they decay, they begin again, and maybe the Earth is alive in more ways than we allow. Maybe time isn't a ruler stretched across space, but a breath held in stone, a pause between one forgetting and the next. Think of the fossils we've found. Trilobites pressed into shale, ferns cradled in coal seams, teeth and tusks and vertebrae scattered across deserts that once were oceans. These are the bookmarks of time, fragile, scattered, incomplete. But for every fossil we find, how many have dissolved? How many were never preserved at all? How many stories turned to dust before we knew how to listen? There's something heartbreakingly gentle about that. The idea that most of Earth's memory has already been erased. But maybe it's not gone. Maybe it's just sleeping. The rocks remember more than they show. Isotopes carry chemical signatures of ancient skies. Ice cores trap whispers of vanished climates. Even soil holds onto what's been spilled, burned, or buried. And yet, what if all these traces are just fragments of a larger tale? What if there was a time before this time? A world before this world, not a fantasy, but a previous arrangement of matter, energy, and life, lost so thoroughly that even its ghosts have decayed? Could it be that Earth has had other histories? Histories we'll never know. Histories that folded into themselves like waves returning to sea. And if that's true, how do we know this one isn't also temporary? How do we know that we are not part of a cycle, that we are not a story Earth is telling right now only to forget again? Maybe time is not a ladder, but a spiral staircase, curving in ways we can't yet perceive. Maybe we are walking over echoes, living atop memories, breathing air that once carried other voices. And if time can be this soft, this circular, this easily rewritten, what does it mean for everything we think we understand? What does it mean for us? And yet, if this much can be lost, what else might we have forgotten? We say Earth is 4.54 billion years old. It's a number spoken with confidence, etched into textbooks and whispered in documentaries. But underneath that certainty lies a quieter question. When did the counting really begin? Not how long Earth has existed, but when we decided it had begun. Time is not something the Earth announces. There is no line in the crust that says, here is the start. Instead, we draw that line ourselves, guided by isotopes, half-lives, and cosmic debris. We turn to the elements uranium, lead, potassium, argon, asking them to tell us when the dance began. Radiometric dating is our most trusted clock. We measure how unstable atoms decay, how one element slowly transforms into another, and we use that steady pace to mark the ages of rock, crystal, and fossil. These clocks tick not with seconds, but with epochs, ticking invisibly, patiently, inside the bones of the Earth. But clocks are only clocks when someone decides what they measure. Before there was a watcher, was there a time to be watched? The oldest minerals we've found are tiny fragments of zircon, found in the ancient rocks of Western Australia, 4.4 billion years old. Just grains of memory, like dust holding onto the scent of a forgotten dream. And still, they are younger than Earth itself. By a margin, yes, but a margin wide enough to carry mystery. We date Earth not by the Earth, but by the sky. Meteorites, silent travelers from the early solar system, carry chemical clues that match the elements of our own planet. We trust these fragments because they seem untouched, unweathered by tectonic folding or volcanic heat. In them, we glimpse the raw ingredients of worlds. But even these spaceborne clocks rely on a beginning that is chosen. We mark the start of Earth from the moment its molten mass began to cool. But why not earlier? Why not when the dust first gathered, or when the first heavy elements were born in stellar fire? What if Earth's true story begins not with rock, but with memory itself? Imagine time before the crust, when the planet was a glowing sphere of magma, reshaping itself each second. Would that world even know time as we understand it? Without atmosphere, without oceans, without erosion or fossils to preserve the moment. Was there truly a clock ticking then, or only motion without memory? We tend to measure time by its remnants, what's left behind, what's visible, what we can hold. But what about the eras that leave no fossils, no layers, no whispers? What about the stretches of existence that pass like breath across glass, gone before the surface ever cools? Could it be that the Earth has had beginnings before the one we honor? Moments where it formed, then unformed, collided, shattered, reassembled. There's evidence, buried in theory, that planets don't always form cleanly. Earth may have had a sibling, a mirror self that once orbited nearby, until they collided violently, silently, and from that union came the planet we walk today, and the moon that drifts above us. If that is true, then our current beginning is already a second draft. Already a story built upon the ashes of a previous one. And maybe that's why the numbers don't feel as settled as they seem. Because we're not counting from the beginning. We're counting from the last time Earth remembered to begin again. Geologists know that the surface is deceptive. The oldest parts of the seafloor are young, mere infants, geologically speaking. The oceanic crust renews itself every couple 100 million years, pulled under by subduction, erased by heat. The continents are older, sturdier, but even they are patchwork, sutured together by ancient collisions and broken apart by time's invisible hand. So we are always dating fragments, always listening to partial stories, always wondering if the earliest pages were torn out before the book was opened. And perhaps that's why the question lingers, not just scientifically but emotionally. Because deep down we wonder, was there a time before time began? Not in the cosmic sense, but here on this ground under our feet. Did something come before the age we call the beginning? A cycle before this one? A memory so old, so thoroughly erased, that even the atoms no longer recall it? Maybe the Earth didn't start once. Maybe it has started many times. Maybe what we call the beginning is just where the light touched it last. And so we keep measuring, not because we know for sure, but because something inside us still hopes the rocks might remember, still hopes the dust might whisper, still hopes the silence beneath the crust might break, softly, into song. And if beginnings are this uncertain, what does that mean for endings? Because every clock we wind eventually stops, and every age we live in eventually folds. And maybe, just maybe, our own time is part of a much longer, older cycle than we dare to imagine. One that has turned before, and will turn again. If time folds, then what holds its creases? What bears the weight of memory long after the moment has passed? It's easy to think of rocks as silent, heavy, final. But what if they're not just matter? What if they're witnesses, not passive things, but storytellers, slowly whispering the shape of ages through their grain and fracture and curve? All around us, stone endures. Beneath our feet, beside our homes, beyond the mountains, there is always rock. And in that rock is a language, not one we're fluent in, but one we've begun to interpret. A soft language of pressure and time, of mineral and fold, of heat and forgetting. The earth records itself in layers. Sedimentary stone, pressed gently by water and weight, keeps the stories of rivers that no longer run and lakes that no longer shimmer. Within these layers are lines, not drawn by hand, but by the patience of gravity and the breath of climate. Lines that mark not just years, but entire moods of the planet. Warm epochs, cold stutters, ancient floods, long droughts, and in between silences. Not everything leaves a mark. Some eras slip through the cracks, unrecorded, like a dream that vanishes upon waking. Erosion may erase 1,000 years in the blink of a geological eye. A continent may rise and fall, only to be scraped clean by ice, rain, or time's persistent fingers. Not because those years didn't matter, but because the stone was too tired to remember them. But some rocks do remember. In the oldest parts of the planet, the cratons, those deep ancient cores of continent, we find stone that has not moved in billions of years. Here the memory is long. Here Earth kept a journal. Bent schists, banded gneiss, the ghost outlines of vanished mountains ground down to root. These are not just relics. They are letters from a planet to itself. Some mountains fold upon themselves, not once, but again and again, like fabric tugged and tucked. The Alps, the Himalayas, the Appalachians, they each carry traces of older mountains buried beneath them, written over like palimpsests. And in those folds may lie chapters of Earth's history we've never read. What might be pressed between those lines? What stories curl inside the seams? Geologists call them unconformities. Gaps in the record where time is missing. Not just missing, but erased. Wiped clean by forces we sometimes understand and sometimes don't. One of the most famous, the Great Unconformity, spans over 1 billion years in places. 1 billion years of vanished time. 1 billion years where stone was either never laid, or was laid, and then taken away. We don't know for sure. We only know there is absence. And sometimes absence speaks louder than presence. Could entire civilizations have risen and fallen in that gap, leaving nothing behind but dust too fine to fossilize? Could ecosystems, mountain ranges, even oceans have existed within that missing time, forgotten not by accident, but by the natural act of planetary breath? We may never know, but that doesn't mean the question isn't worth asking. Because every stone we touch once lived closer to the center of something. Closer to heat, closer to the heart. Through metamorphism, sediment becomes slate. Limestone becomes marble. Shale becomes schist. Nothing stays as it is. Even memory transforms. Maybe the earth doesn't remember clearly. Maybe it remembers in fragments. But even fragments can hold truth. Look closely at a cliff face, see how it leans. Notice the diagonal lines, the jagged interruptions, the shifts in color and texture. These are not flaws. They are bookmarks. And if you learn to read them, they tell of floods and fires, of sudden burial, of long stillness broken by earthquakes or eruptions. Some rocks even capture moments more personal. A ripple pattern, frozen in sandstone, records the shape of a shallow sea stirred by wind. Raindrop impressions, stamped into ancient mud, speak of a single storm, one afternoon, hundreds of millions of years ago. The footprint of a creature long gone, pressed forever into stone, becomes a whisper across the abyss. Not because it was loud, but because it was left behind. And this is the strange beauty of stone. It does not shout. It does not rush. It does not beg to be seen. But it waits, patiently, quietly, beneath our cities, beneath our farms, beneath the oceans, waiting for us to remember how to listen. Because when we treat the earth as still, we miss the motion within it. We miss the rewrites, the forgettings, the second chances, and the quiet resilience of a planet that keeps walking forward, even when no one is watching. So the next time you touch a rock, pause. You're holding a piece of memory. You're touching time. You're brushing against an era that may never have had a name, but still mattered. And if stone can hold so much, what else might be hiding in the layers we've yet to uncover? What else sleeps beneath the surface, just waiting to be seen again? Some things do not sleep. Some things leave echoes so strange, so quietly out of place, that even time itself seems to hesitate around them. We call them fossils, but not all fossils tell familiar stories. Some confuse us. Some challenge the neat narrative we've built. These are the fossils that shouldn't exist. And yet, somehow, they do. We think of fossils as the evidence of life. Bones turned to stone, plants pressed to carbon ghosts. We build timelines from them. We trust their place in the strata. And most of the time, they behave. Most of the time, they fit. But sometimes, they don't. Sometimes, we find a footprint where there shouldn't be a foot. A tooth in a layer too deep. A pattern etched in stone so old, it predates the conditions required to preserve it. And in those moments, the story falters. Not loudly, not completely, but just enough to leave a question suspended in the air. Could life have risen and fallen before we ever arrived? In the high desert of Nevada, trilobites, ancient sea creatures older than dinosaurs, have been found perfectly preserved in layers that once lay beneath warm, shallow seas. But nearby, in stone thought to be even older, faint impressions suggest movement, crawling, coordination, behavior. What if the story of life on Earth is not a single crescendo, but a song played more than once? The fossil record, for all its depth, is incomplete. Deep time is a sieve. Only the hard parts survive: shells, bones, bark. The soft, the subtle, the strange. These tend to dissolve, decay, disappear. And so we assume they never were. But maybe that's a mistake. The Cambrian explosion, 541 million years ago, is often called the dawn of complex life. But what if it wasn't an explosion, but a return? What if the complexity we see bursting forth was actually recovering, repeating, after a previous silence? There are fossils older than the Cambrian. Trace fossils, burrows, patterns in the mud. Nothing definitive. Nothing dramatic, but hints, clues, movements that speak of a hidden chapter. We walk through places like Mistaken Point in Newfoundland, where soft-bodied ediacaran organisms lie flattened in volcanic ash. Their forms are strange, not quite animals, not quite plants, frond-like, symmetrical, and entirely unlike anything living today. They appear suddenly, and then vanish. No descendants, no clear purpose. Just a brief, beautiful page in Earth's long book, now closed. Why did they disappear? Or maybe more curiously, where did they come from? Could these be the remnants of a trial run? A forgotten wave of life that rose before our familiar branches took root? Even stranger are the outliers, the ones that don't belong. The shoe print found in 500-million-year-old limestone. The hammer encased in rock that seems impossibly ancient. The carved stone spheres unearthed in Precambrian soil. Most of these are explained away, misinterpretations, hoaxes, anomalies of geology. But even if just one were real, what would it mean? We are trained to be cautious, to trust consensus. And rightly so. Science moves carefully not because it is afraid, but because it is listening. Still, sometimes even science pauses at the edge of mystery and waits. The truth is, we do not know what Earth has forgotten. We do not know what erosion has erased. Entire landmasses have vanished beneath the sea. Entire ecosystems have been ground to dust. And fossils, for all their endurance, are delicate things. They require perfect timing. The right sediment, the right chemistry, the right stillness. Most life, almost all of it, leaves no fossil at all. So what if something extraordinary lived here once? What if it left behind no bones, no fire pits, no tools? What if it dissolved back into the soil before we ever learned to dig? Would we know? Could we know? Some scientists now study the concept of technofossils, artifacts left by modern civilization that may one day be all that remains of us. Plastic, concrete, nuclear isotopes embedded in rock. These traces may outlast us, but even they will fade. Even they will break down. So if another civilization came before us, tens or hundreds of millions of years ago, what would be left? Would we recognize it? Would we even know what to look for? Or would we dismiss the signs because they do not fit the story we already believe? There is humility in the fossil record. A quiet reminder that we are not the first to walk, to breathe, to wonder. We may not even be the first to forget. And as we linger with these strange impressions, these impossible fossils, we're left not with answers, but with a feeling, a soft tug in the chest, a tilt in perspective, a whisper beneath the surface of stone. What if life is more persistent than we realize? What if memory leaves traces in forms we haven't yet learned to see? And if the fossils that shouldn't exist do, what else might be hiding in the layers below? What else waits to be found? Not because it's loud, but because it's still here. Sometimes, the things that disappear don't vanish all at once. They move slowly, quietly, like a dream slipping back into darkness before morning wakes us. Earth, too, has its own way of forgetting. Not through silence alone, but through movement, through drift. Continents don't sit still. We think of them as permanent, as the stage beneath our stories. But they move always. They slide across the mantle like memory gliding beneath consciousness. Inch by inch, lifetime by lifetime, a motion so slow we forget it's happening, until the shapes on the map begin to shift. This is plate tectonics, a planetary waltz, set in motion by the heat within. Driven by convection currents deep in Earth's mantle, crustal plates float like cracked ice atop a molten sea. Sometimes they drift apart, sometimes they collide. And with each movement, the surface of the world rearranges itself. But this dance doesn't just reshape mountains and oceans. It buries stories. It erases the outlines of entire landscapes. It folds memory beneath new stone, locking it away from the surface and from us. Once all the continents were joined. A supercontinent, Pangaea. Before that, there was Gondwana, and before Gondwana, Rodinia. Each one rose and broke apart. Each one gathered forests, rivers, creatures. And each one was eventually swallowed, not by catastrophe, but by time's quiet rearrangement. When continents collide, mountains rise. But below the uplift, beneath the peaks, something else happens. One plate begins to sink. It subducts. And in that sinking, the crust and everything on it is pulled into the Earth's deeper layers. Not just rock, but fossils, soil, coastlines, civilizations, if they were there, erased so slowly we wouldn't even know they had vanished. Could memories be hiding in these zones of subduction? Entire ages quietly descending into heat and pressure? Subduction zones are graveyards for geologic memory. The seafloor, which spreads outward from mid-ocean ridges, eventually finds its end in these deep trenches. There, it bends and folds downward, taking with it the accumulated dust of eons. The records vanish into the mantle, and with them, the proof. And yet, sometimes pieces come back. A fragment of oceanic crust may be thrust upward, caught in the jaws of a continental collision. These slivers, called ophiolites, are glimpses of the deep, a rare chance to read the lost pages before they're fully consumed. But most are not so lucky. Most are melted, remade, returned to the Earth's interior, where time no longer keeps the same rules. And if that's true for geology, could it be true for history? Could entire chapters of life, thought, and culture be buried not just beneath dust, but beneath the crust itself? We may never know what lay on those ancient shores before they sank. Not because it didn't matter, but because the Earth does not hold still for memory. Keeps going. It remakes its own surface like paper recycled again and again until the original words are gone. Even continents forget themselves. The shapes we know today, Africa, Asia, the Americas, are temporary. Like clouds drifting across a deeper sky. Give them a few 100 million years, and they'll merge again, or shatter further. A future map none of us will see. But the land remembers in its own way, in scars, in seams, in minerals squeezed by impossible pressure, crystalline records of trauma and transformation. And sometimes, just sometimes, we find a match. A rock in Antarctica that mirrors one in India. A fossil in South America that mirrors one in Africa. Proof that once these lands were not separate. They were part of the same breath, the same ecosystem, the same forgotten age. And if the land can reunite, if stone can drift and return, what else might come back? What else might rise again, not as fact, but as possibility? The slow drift of continents is not just a physical process. It is a metaphor for memory itself. It reminds us that what feels stable is always in motion, that what feels lost may simply be moving, just beyond reach. And maybe, just maybe, beneath the ocean floor or folded deep within a mountain range, there are pieces waiting, not to be discovered with certainty, but to be wondered about, to be felt in the bones, to be dreamt into curiosity. Because when the ground itself cannot hold still, how can we expect our stories to? And if land can forget, if memory can subduct, what happens to the history that never had a chance to fossilize at all? It sinks, not just into myth or memory, but into matter, into soil, into sediment. Earth has a habit of hiding its oldest truths in layers, not because it wants to deceive us, but because that's simply how it breathes. Every flood, every drought, every slow crumble of mountain into dust, leaves behind a trace, a soft imprint, a gathering of quiet. And over time, these layers become something more. They become archives. The sediment beneath us, sand, silt, clay, gravel, is not just the stuff of land. It's the residue of stories, worn from peaks and carried by rivers, spilled into valleys and lakes and shallow seas. Each grain of sand once belonged to something larger, something older, a mountain, a shoreline, a forest floor, a story. And when that sediment settles, when it comes to rest, it begins to remember. We think of fossils as bones, but the truth is, bones are rare. Most history is carried not in skeletons, but in the spaces between. In pollen trapped in clay, in charcoal flakes hidden in floodplains, in microscopic shells gathered in ancient seabeds. Some of these layers predate everything we've carbon dated. Carbon itself fades beyond 50 or 60,000 years, but the sediment goes deeper, far deeper, down where radiocarbon clocks no longer tick. The silt still whispers, in isotopes, in trace metals, in subtle changes of color and composition. Buried river deltas tell of rainfall that lasted millennia. Lost deserts record winds that blew before mammals evolved. Ocean floors, those vast, unseen archives, carry the dust of continents, the ash of volcanoes, the hushed fall of plankton through water darker than night. We send drills deep into these deposits. pull up long cores of layered earth. And we read them like tree rings but older, more fragmented, less certain. Still they speak. They speak of climate, of extinction, of rebirth, and sometimes of silence. Because not all sediment is equal. Some layers arrive with violence, rapid floods, landslides, collapses. Others drift slowly, almost imperceptibly. A millimeter a century, a soft snow of minerals, life, and loss. And in those slow layers, there may be things we've missed, or things we've mistaken. Because sediment is not just a passive recorder. Transforms, compresses, turns soft earth to shale, sand to sandstone, mud to stone, and in the process it folds the past into itself, changing shape, losing detail, but never fully letting go. Sometimes we find signs of fire, ancient soot layers spread across continents, as if the sky burned and the earth blinked. These could be the fingerprints of impacts, or of civilizations. We don't know for sure. Other times we find subtle changes in isotope ratios, carbon, oxygen, nitrogen, that speak of planetary shifts too large to see, but too loud to miss. And still deeper we find absence. Gaps where layers should be but aren't. Not because nothing happened, but because something happened too much, too fast, too completely, and the sediment could not hold it. What stories were washed away in those missing years? What voices drowned, not in water, but in time? There are ancient seabeds now locked into mountaintops. Once at the bottom of the world, they now look down on clouds. Their secrets lifted skyward by tectonic forces, or exposed by erosion, like wounds reopening. Other sediments remain buried, beneath our cities, beneath our oceans, beneath the places we never think to dig. Some of these layers have not seen daylight in 100 million years. And they wait, not because they know we'll come, but because that's what layers do. They wait, they hold. Soil is more than just ground. It is a kind of memory, a living one in constant motion, full of microbial life, full of chemistry, full of potential. And sand is what remains after everything else has broken. Sand is the echo of the past, ground down so fine it slips through fingers. Still, it carries weight. Still, it tells us where the wind has been, where the water once flowed, where the earth once dreamed. And if we listen closely, if we trace the patterns in the deepest sediment, we may find shadows of stories we didn't know we were missing. Not all memory looks like evidence. Sometimes it looks like mud. Sometimes it looks like dust. Sometimes it's hidden in the tilt of a single grain, or the color of a forgotten clay. And if even the ground can hold this much, what might the oceans be hiding? What waits in the dark, wide silence beneath the waves? Sometimes it's not what we see that tells us the truth. Sometimes it's what atoms remember. Even when fossils fade, when sediment shifts, when maps dissolve and bones return to dust, atoms hold on. They decay, but they do not forget. They change, but in changing they leave behind something else. A whisper, a rhythm, a trace of time not in years or calendars, but in ratios, in chemistry, in echoes. These are isotopes. At first they seem invisible, ghosts of elements, versions of the same thing but slightly heavier, slightly less stable, slightly more willing to dissolve into something new. Carbon 12, carbon 14, uranium 238, thorium 232, potassium 40. The numbers are the only difference, and yet, in that difference lies the clockwork of Earth's deep past. We trust isotopes like we trust the stars. They decay at known rates, slow, steady, patient, a half-life here, a half-life there. And by measuring how much of one isotope remains, and how much has changed into something else, we tell time. We assign ages. We place markers in the void. But even these quiet clocks sometimes hum with something unexpected. Even isotopes raise questions. Carbon-14 is one of our best tools for measuring recent history. Tens of thousands of years back, like a torch flickering in a long corridor. It's found in organic matter, absorbed by living things, and begins to decay once death interrupts the cycle. But go further back, beyond 50,000 years, and the signal fades. The torch dies, and we're left walking in shadow. That's where uranium and thorium step in. These elements decay more slowly. They help us peer into rock, into coral, into cave deposits that reach back hundreds of thousands, even millions of years. Their ratios reveal the shifting of climates, the rise and fall of sea levels, the breathing of glaciers. But not all readings align. Some samples return dates that don't match the story we expect. A stone reads older than the layer it lies within. A fossil contradicts the age of the rock around it. An isotope ratio suggests a cooling when everything else points to heat. These aren't failures. They're invitations. Invitations to look closer, to wonder what cycles we haven't yet uncovered, to ask whether time moves only forward, or if it swirls. Oxygen isotopes, for example, tell us about ice. The lighter isotope, oxygen-16, evaporates more easily than its heavier sibling, oxygen-18. During colder periods, more oxygen-16 gets trapped in glaciers, and the ratio in the ocean shifts. We can measure that. We can build a curve, an echo of the planet's breathing across hundreds of thousands of years. But even this breath skips sometimes. There are interruptions. Moments where the ratio swings too far, too fast. Moments when the climate changes not in slow waves, but in sharp pulses. What causes these jolts? Volcanoes? Solar shifts? Something else entirely? We don't always know, but the isotopes notice. They carry the signal forward, quietly, through bone and coral, through stalagmites and ocean floor ooze. Sometimes we even find isotopic anomalies that defy planetary origin. Layers of sediment enriched with rare isotopes like iridium, an element more common in asteroids than in Earth's crust. These anomalies mark impact events like the one that ended the age of dinosaurs. But what if there were others? What if some isotopic scars belong to events we've never named? There are also whispers of nuclear signatures, unusual concentrations of plutonium, cesium, or other artificial isotopes buried in recent sediment. Reminders of our own presence, our own brief, bright flash upon the record of Earth. A new layer, a new echo. We are now part of the isotopic story. We are now traceable. And so the record continues. From the radioactive heart of a zircon crystal in the oldest crust, to the carbon locked inside a charred piece of driftwood, to the oxygen frozen in a bubble beneath Antarctic ice. Atoms remember in ways we can't. They do not care for politics or poetry. They are not loyal to our narratives. They only shift, decay, drift, and in doing so they leave a trail. And yet, even they cannot tell us everything. Even they carry gaps, noise, mystery, because for all our measurements, there are cycles we still don't understand. Isotopic evidence of climate swings that repeat every 100,000 years, without a clear cause. Chemical traces that suggest ancient fluctuations in Earth's magnetic field, or in solar radiation, or in something else, something larger, perhaps, than our models can hold. Could it be that these isotopic echoes belong to forgotten influences? Unknown celestial rhythms? Civilizational waves that rose and fell without leaving monuments, but left behind a subtle shift in the chemistry of air and soil? We can't be sure, but we can listen, because even the smallest atom remembers, and in those silent memories, buried in stone and bone and salt, Earth may be trying to tell us a story we haven't yet learned to hear. And if the tiniest traces can carry so much, what about the silences between them? What might be hiding not in the echoes, but in the quiet spaces they leave behind? Sometimes, it's not the signals that tell the deepest truths, but the silences. After all, when something ends, the world does not scream. It breathes out, falls quiet, and that quiet stretches slowly into time. After every extinction, silence blooms. It doesn't look like absence right away. It looks like still forests, empty seas, soil without tracks, sky without birdsong. Then slowly it begins to show, in the missing bones, the vanished branches of evolution, the strange gaps in the fossil record where something should be, but isn't. We know of 5 great die-offs. 5 times when life on Earth was abruptly, profoundly altered. Not through slow decline, but through sharp planetary change. The first came some 443 million years ago, the Ordovician-Silurian extinction. A cooling world, falling sea levels, the oceans themselves collapsing inward. Nearly 85% of marine species erased. Not because of fire or impact, but because the balance shifted. And the silence rose. The second, the late Devonian, was slower, stranger. A long unraveling. Plants colonizing land, altering the atmosphere. Algae blooms choking oxygen from the water. Coral reefs fell quiet. Fish vanished. The earth tilted, and life held its breath. Then came the most devastating of all, the Permian-Triassic extinction, 252 million years ago. Sometimes called the Great Dying. Over 90% of all species lost. Oceans turned acidic. Methane surged from seafloor clathrates. Volcanoes may have darkened the sky. For a time, there may have been more silence than sound. Later, the Triassic-Jurassic event reshaped life again, clearing the way for dinosaurs, but only after immense loss. Another purge, another pause, and then 66 million years ago, the one we know best, the Cretaceous-Paleogene extinction. The end of the dinosaurs. An asteroid, a sudden flash, the world caught fire, dust blocked the sun, plants died, the food web collapsed, and the silence that followed was long. Long enough for mammals to rise, for forests to regrow, for a new world to unfold. Each extinction is a kind of punctuation, a reset. But what's often forgotten is the space afterward. The stillness, the empty niches, the slow creep of life back into the world. Because extinction doesn't just remove life, it removes memory. Whole ecosystems gone before they can fossilize. Whole lineages severed, their stories untold. And that raises a gentle, unsettling question. Were there others before these 5? Others we've lost not to death alone, but to erosion, to entropy, to time itself? We name the 5 mass extinctions because they left traces. Patterns in the rock. Abrupt changes in isotopes. Sudden shifts in fossil diversity. But the deeper we go, the harder it is to see. Rocks grow older, yes, but they also grow fewer. They melt. They fold. They vanish into tectonic drift. Could there have been an earlier storm? A die-off before bones were hard enough to fossilize? Or before sediment could catch the fall? The early history of life before the Cambrian period is full of murk. Life was soft-bodied, microscopic, rarely preserved. Entire kingdoms may have come and gone without leaving a mark. And yet, even now, there are strange signals. Sudden shifts in carbon isotopes. Global drops in biodiversity inferred from genetic studies. Gaps in stromatolite formation. Are these signs of forgotten extinctions? Or merely noise? We don't know. But silence leaves a shape too. And sometimes the shape is enough to wonder. Extinctions are not just moments of loss. They are reflections of a planet in flux. A reminder that Earth is not static, and life here is not guaranteed. That even in its resilience, even in its beauty, this world forgets. And starts again. Over and over. And each silence leaves behind a different possibility. After the Permian extinction, reptiles grew large. After the Cretaceous, birds diversified. Mammals expanded. Forests evolved. The quiet gave way to new songs. But it also buried the old ones. And that, perhaps, is what lingers most. The knowledge that some songs have ended forever. Not because they were weaker, not because they failed, but because the sky changed, or the oceans warmed, or the air turned sour, just long enough to close a chapter no one knew was being written. And if that can happen 5 times, could it happen again? Or could it have happened 6 times? 7? 10? Extinctions leave gaps. And in those gaps we project hope, fear, wonder. Because even as we walk forward into the Anthropocene, into the age where we shape the world, we carry the echo of every loss behind us. Every silence, every storm. And if silence can bloom with such finality, what else might it conceal? What stories were written in species we never knew? What memories dissolved with the last breath of something that had no name? And if we've already forgotten this much, what more are we still not hearing? Sometimes, what we fail to hear isn't a silence. It's a whisper from far away, older than fossils, older than stone, older than earth. There is a kind of dust that doesn't come from wind or sand, or the crumble of time-worn mountains. It doesn't settle from rivers or rise from the footfalls of life. It comes from stars. Not just the light of them, but the bones, the cooled embers of distant, dying suns. This dust, pre-solar grains, drifts through the galaxy for millions of years, until one day, it finds itself caught in something new. A swirl, a pull, a cloud of gas collapsing inward, birthing a star, and around it, a small rocky world just beginning to take shape, Earth. But long before Earth had oceans, before it had an atmosphere or even a surface to stand on, this cosmic dust was already here, folded into its body, embedded in its minerals, resting deep in the rocks we now call ancient. And in that dust is memory. Some grains are over 7 billion years old, twice the age of Earth itself. We've found them in meteorites, those wandering messengers of the early solar system. They carry isotopic fingerprints no known planet could have produced. Ratios of oxygen and silicon and noble gases that only exist in the cores of long-dead stars. We call them anomalies, but maybe they're reminders. Reminders that Earth did not begin cleanly. It began with inheritance, born not as something new, but as something reassembled. A second draft, made from the ashes of older worlds. And maybe that's why some questions never quite resolve. Why the deeper we dig, the more ancient things begin to blur. Not just into deep time, but into deep space. Because we are made of the same dust. We walk on it, breathe it, drift with it, and that dust remembers. It remembers things we've never seen. It remembers the collapse of stars, the burn of hydrogen into helium, the forge of carbon in stellar hearts. It remembers the moment those stars could no longer hold their shape, and exploded, scattering their elements across space like a final breath. And out of that breath came us. Meteorites carry this memory, too. Some are made of carbonaceous chondrites, among the oldest materials in the solar system. Inside them, we find calcium-aluminum-rich inclusions, some of the first solids to condense after the birth of the sun. Others contain water-bearing minerals, perhaps the very seeds of our oceans, delivered from afar. So when did Earth begin? Was it when the molten rock cooled? When the core solidified? When the first continent rose from the sea? Or was it earlier? When ancient stardust gathered in a disk around a newborn sun, long before the word planet had meaning. Maybe Earth has no true beginning. Maybe it's always been becoming. The atmosphere, too, holds ancient clues. The nitrogen we breathe, the oxygen we depend on, the trace gases that shift with each epoch. They all carry isotopic signatures, tiny imbalances in atomic weight that reveal where they've been, how they've changed, what they passed through. Even the air remembers in its own way. Frozen bubbles in polar ice cores tell us of volcanic winters, solar cycles, mass blooms, and mass losses. They hold the breath of extinct forests, the sighs of glacial melt, the long exhale of a warming sea. And still, the trail goes further, back to a time when the sky was poison, when methane ruled and life was microscopic and uncertain, before oxygen, before the blue, before memory had words. And yet, the dust was still here, the same dust that drifts past us even now, falling invisibly each day, a fine sprinkle from space. It lands on rooftops, forests, oceans, eyelashes. We almost never notice it. But every year, Earth gains thousands of tons of interstellar material. We are still gathering the stars, still building ourselves from memory not our own. And so we begin to ask, did Earth begin before Earth began? Is our story the product of this planet alone? Or are we a chapter in something larger? Something stellar, cyclical, recursive? Something that remembers itself only through matter? Because memory here does not need a mind. It only needs time. And the smallest particles of that time are still arriving, still whispering, still falling, one grain at a time, into the vast soft archive we call home. And yet, not every memory remains. Some are too fragile, too exposed, too slow to be saved. Because time does not only preserve, it erodes. Not quickly, not violently, not most of the time, but gently, patiently, as if forgetting is the Earth's way of resting. We tend to think of destruction as loud. Volcanoes, earthquakes, fire. But the greatest force of change on this planet is quiet. It doesn't crash, it carves. It doesn't shout, it wears away. Erosion is this soft, persistent undoing. A raindrop lands on stone. It seems harmless, but another follows, and another, and over years, decades, centuries, the stone begins to change. Its edges soften. Its lines blur. Eventually, the shape is gone, and only the dust remains. Rivers trace their fingers through valleys, pulling fragments of mountain into the sea. Glaciers drag rock like slow knives across the land, grinding everything beneath them into silence. Wind whispers through desert stone, lifting grains of sand that polish the world down to bone. This is how truth fades, not in one moment but in the absence of resistance. What once stood tall cities, forests, cliffs, may now be plain, or ocean, or sky. And the most unsettling part is, we rarely know what's missing. We can only guess. We see a plateau and wonder what once covered it. We walk through a canyon and imagine the miles of stone that used to fill it. We find isolated fragments, a fossil without a skull, a wall without a foundation, a tool without a culture, and try to write stories from pieces that time forgot to keep. There is a term geologists use, denudation, the long, slow stripping of the Earth's surface, layer by layer, era by era, the smoothing of mountains, the washing away of what once was. But denudation doesn't just change landscapes. It erases context. Without context, a fossil becomes a puzzle piece without a picture, a strange shape with no clear fit, an artifact without a story, a voice without its language. What if entire histories have been lost this way? Not by accident, not by conspiracy, but by weather, by the wind blowing for a little too long in one direction, by a river wandering just slightly off course, by a glacier that didn't know it was erasing something precious. Even civilizations, if they existed long before our own, could be erased this way. Wood returns to soil. Mud bricks melt in the rain. Metal oxidizes. Bones dissolve. And all that remains is the stone beneath. The same stone we walk across every day, not realizing what may have once stood there. We tend to believe the past is solid, knowable. If something was real, surely we could find it. But erosion reminds us otherwise. Erosion teaches humility, because even the hardest truths can fade. Even the most permanent things aren't permanent at all. And the longer we look back, the more the past begins to blur. Not because it wasn't there, but because time has run its fingers through it too many times. In some places we find inverted relief, hardened channels that once were rivers, now standing above the landscape they carved. The soft around them is gone, and what remains is not the river itself, but its echo. Elsewhere we find inselbergs, isolated hills rising from vast plains, survivors of erosion, lonely fragments of what once might have been an entire range. The earth doesn't erase evenly. It forgets in patches. And in between those patches, we guess. We reconstruct. We imagine. We draw maps of what we think was once there. And sometimes we're right. But sometimes we're only tracing shadows. And if shadows are all that remain, how do we know what's true? How many ages have passed beneath our feet without us knowing? How many stories have been smoothed flat, like carvings on stone worn clean by centuries of rain? How many truths were never written in bone, or metal, or fire, but in something softer, something that vanished before we even learned how to see? Erosion is not the enemy. It is part of the rhythm, a necessary return. But it reminds us that memory, real planetary memory, is incomplete. It always will be. And so we listen, we dig, we guess, we imagine. Not because we expect the whole story, but because we hope for a glimpse, a fragment, a grain of truth that time somehow missed. And if so much can be erased this easily, what happens to the things that were never written down at all? Maybe they vanish, or maybe they transform, not into myth, not into memory, but into matter, into trace, into fragments so quiet and so altered by time, we no longer recognize them for what they were. And that leads us to a question both haunting and strange. If a civilization came before us, would we know? Would it leave a mark? Would it leave anything behind at all? This is the heart of the technofossil paradox. It begins simply. If a technological species once walked this planet, long before us, long before written language or metal tools or even recognizable bones, then where are the traces? Shouldn't there be something? A machine, a city, a layer of refuse, a scar on the earth too artificial to ignore. And yet, there is nothing conclusive, nothing loud, nothing lasting. But maybe that's the paradox. We assume that industry endures, that machines will outlast their makers, that a civilization as advanced as ours, if not more, would scatter unmistakable signatures across the geologic record. But how long do our own traces really last? Steel rusts, glass fractures, concrete weathers, plastic floats, yes. But even it is breaking down, and deep time doesn't rush. It waits. A city left alone, abandoned, can disappear in centuries. Jungle reclaims. Earth swells. Dust settles. 1,000 years can bury almost anything, especially if time wants to forget. But geologically, 1,000 years is nothing. Even 1,000,000 years is just a blink. Now stretch that further. 10 million, 50, 100 million years of erosion, subduction, glaciation, desertification, flood. Plate tectonics moves continents across the globe. Oceans open and close. Mountains rise and fall. The crust itself is recycled. So what survives? What could a civilization leave behind that would last? Some suggest we're already leaving it, technofossils. Not bones, but byproducts. Synthetic materials unknown to nature. Plastics, aluminum alloys, nitrogen compounds, nuclear isotopes, concrete layered thick in our urban centers. These things, unnatural, uniform, strange in their persistence, may be what the future reads as our fossil. But even they are fragile. Plastics degrade under pressure and time. Radioactive isotopes decay into invisibility. Metals corrode. And the deeper into the earth these traces are pushed, the more likely they are to melt, blend, vanish. So we wonder, if we vanish tomorrow, how long before the planet smoothed us away? 10,000 years? 1,000,000? What would remain? Perhaps only a faint chemical shift in the soil. A layer of soot, like the ones we associate with wildfires or volcanic winters. A sudden spike in carbon, or rare isotopes, or a thin seam of microplastics laid into future sediment like some indecipherable script. Would that be enough? Would a future intelligence, human or not, look at that layer and see culture, memory, technology? Or would it seem like just another environmental hiccup, one more anomaly in Earth's long, restless breathing? And if we struggle to recognize our own signature, how could we ever be sure we'd see someone else's? Maybe we've already missed them. Maybe some anomaly we've cataloged, some oddity in the data, some unexplained layer, some ancient spike in temperature or metal concentration, isn't natural at all. Maybe it's what remains of someone else's moment. Their machines, their cities, their choices, melted, buried, erased. And we didn't recognize it because we didn't know what to look for, or because we weren't ready to ask. Because the idea itself unsettles the neatness of our story. We want to be first. We want to be original. But maybe Earth is older than that. Maybe it's practiced. Maybe it's been home to more than we imagine. Not mythic civilizations with pyramid-shaped spaceships and laser wars, but cultures, minds, societies that shaped their world briefly and then were shaped by it in return, folded back into stone. washed into silence, just like ours may one day be. And so we return to the paradox. A civilization advanced enough to alter the earth might be advanced enough to disappear from it completely, to erase itself cleanly, or to be erased, or to be misread as a curious fluke. And we, walking over their ashes, would never know, unless we start listening differently, unless we stop asking only what survives, and begin to ask what might have slipped through. Because if machines once hummed before us, and cities once rose and fell, and knowledge once lit the night with fire and signal and code, then the earth, somewhere deep beneath its surface, still carries their shadow, faint, folded, waiting. And if we could recognize that shadow, what else might we see in the layers we've already passed? Maybe something that no longer looks like what it was. Maybe something buried so deeply, it has been changed, folded, melted, silenced. We like to think of cities as permanent, tall, anchored, visible from the sky. But permanence on this planet is a temporary illusion. Earth is not still. Earth is not passive. It moves, breathes, forgets, and sometimes it swallows. Could it swallow entire cities? Could there be ruins not just beneath soil and sand, but beneath crust? To ask this question is not to claim an answer. It is to descend, to sink gently into the folds of possibility, into the deep zones where tectonic plates meet, and one is pulled slowly beneath the other. These are the subduction zones, the gates to the mantle, the places where the surface of the world is returned to its interior. What vanishes here rarely returns. The oceanic crust, younger and denser, slips beneath the continents at a pace slower than fingernails grow. With it go sediments, microfossils, buried carbon, and every trace of what rested atop the seafloor. And with enough time, millions of years, these things are compressed, heated, and absorbed, their shapes erased, their structures transformed, their stories dissolved. So, what if something more once stood on those now subducted plains? Not ships or skyscrapers, perhaps, but settlements. Not satellites, but symbols, traces of minds, of culture, of intent. Would we find them now? Or would they be gone? The oldest parts of the ocean floor are only about 200 million years old. That sounds ancient, but geologically it's brief. Continents hold stones 4 times older. The seafloor is constantly renewed, its edges drawn back into the Earth's heat, like fabric slowly unraveled from beneath. If any city, ours or another, had been built on such shifting ground, it would not have lasted long. It would have been erased by motion, by pressure, by fire. But beneath the continents, in places not yet pulled under, some shadows may linger. Buried plains, ancient river deltas now kilometers deep, sediment beds thicker than mountains, compacted beneath newer crust. We drill into them sometimes for oil, for gas, for data, but even our deepest boreholes barely scratch the surface. The Earth's crust is vast and layered and full of blind spots. It is possible, just possible, that some evidence waits there, not as buildings, not as machines, but as anomalies, odd formations, unusual isotope signatures, mineral arrangements that suggest heat or structure or pattern that nature doesn't typically make. We would not recognize them as cities. We would not even recognize them as deliberate. But maybe that's the challenge. Not that they are hidden too well, but that we are not yet trained to see. Because over time, even stone forgets its purpose. Even metal returns to ore. Even glass becomes sand again. All the things we build, roads, homes, spires, are made from Earth's ingredients. And to the Earth they will return. But perhaps not without a trace. Subduction isn't always total. Not everything melts. Sometimes, fragments are thrust upward again in orogenic zones, places where continents collide and fold into mountains. In those folds, geologists have found pieces of seafloor, ancient sediments, even traces of past life pressed impossibly deep and returned, altered but still legible. Could something else rise? Someday? Some fragment of a buried age, thrust up in a mountain range we haven't yet imagined? Could it be misread as natural? Or passed over entirely? There is humility in this kind of thinking, in remembering that the planet is older than all our categories, that it has rearranged itself not once, but many times, that what lies beneath may not be fossils or fire, but fragments of forgotten intention. Because if a city was buried, and we found it, would we even know what it was? We expect structure, symmetry, metal, artifact, but what if time left only chemical scars? What if memory could only survive as pattern? We are already building cities that stretch downward, subways, caverns, deep mines. As we do, we disturb layers that have been asleep for millennia. And yet, we rarely ask what lies just below that reach. Not in metaphor, but in stone. Maybe no civilization ever came before. Maybe there are no cities beneath the crust. But maybe there are. Maybe they're not cities as we define them, but concentrations of thought, of presence, of forgotten design. Not carved in stone, but pressed into it. And if we never look, we'll never see. And if we never listen, we'll never hear. Because the crust isn't just a barrier, it's a veil. And beneath it, Earth might be holding more than we're ready to understand. Especially when we look toward the sea. The ocean has always been a keeper of secrets. It does not resist forgetting the way land sometimes does. It accepts, folds, preserves, and then, slowly, it drowns what once was in silence. But the ocean is not just a place of loss. It is a library, a vast, dark archive where memory settles gently through water, falling as dust, as plankton, as ash, falling day after day, for millions of years. What rests at the bottom is more than just debris. It is the patient record of Earth's breath. We drill into it, into the deep sediment beneath the waves, and extract long, slender cores of memory. Each centimeter holds a century. Each meter reaches back into epochs we've never seen. Climate, extinctions, eruptions, shifts in chemistry and temperature. It's all there, sealed beneath miles of pressure and darkness. But what else might be there? What else has been recorded in the deep? Long ago, sea levels were not as they are now. The coastlines of Earth have shifted like tides across the ages. When the ice was thicker, more of the ocean was locked into glaciers, and the sea receded. Land bridges formed. Shelves of Earth stretched outward from the continents. Broad, fertile plains now hidden beneath the surf. People may have walked there. Herds may have moved across them. Villages, perhaps even cities, might have rested at the edge of vanished shores. Now they are gone. Not destroyed, just drowned. Submerged beneath 100 meters of water. Beneath waves and currents and silt. What remains of them may be buried in sandbanks or entombed in layers of salt. Not easily found. Not easily known. We speak of Doggerland, a lost land beneath the North Sea, once home to animals and people at the end of the last ice age. We speak of Beringia, the bridge between Asia and North America, now hidden beneath the cold. We speak of Sundaland, a vast drowned region of Southeast Asia. These were not myths. These were places. And now they are pages missing from our story. But could there be more? Could there be forgotten cultures resting on the continental shelves? Could the ocean, in its endless patience, be keeping them safe from our forgetting? The challenge is depth, pressure, visibility. What we call the seafloor is not always a smooth plane. It is broken, folded, scattered. Sonar gives us outlines. ROVs give us glimpses. But the ocean does not yield its past easily. Sometimes we find things, structures, arrangements, patterns that look like ruins. Underwater stone circles, walls, roads. Some are natural. Some are harder to explain. And always the sediment keeps falling. Layer after layer. Even plastic and radiation have now found their way into the deep. We're adding our own chapters to the marine archive. But far beneath that, deeper than our memory, lie stories we haven't yet read. Oceanographers speak of turbidites, underwater landslides that bury and preserve whole layers of sediment in an instant. They speak of oxic and anoxic zones, places where life is either vibrant or completely still. In those still places, decay slows. Bones can last longer. Would even fabric might survive? If there were tools, if there were words, if there were signs of thought, would they be waiting there? Not on the abyssal plains, but closer, just beyond our modern coasts. Beneath the calm waters of bays, beneath the weight of silted deltas. There is no certainty, only questions, only patterns in sand that flicker beneath current and light. But what if, once, the ocean was not just a boundary but a book? What if it recorded more than we expect? Not with ink but with pressure. Not with chapters but with layers. What if entire cultures whispered into the sea, and the sea held them quietly all this time? We may never know for sure, but still we look. We scan the seabed for symmetry. We measure anomalies in magnetism. We trace ancient shorelines with satellite maps. And with each discovery, the story of the sea grows stranger, older, wider. Because the ocean does not forget in the same way the land does. It just buries things deeper. It holds them longer. And sometimes, just sometimes, it gives them back. A fossilized shell. A carved fragment. A lost tool surfaced by tide or storm. A breath of a world we didn't know we'd lost. So maybe the ocean is more than a mystery. Maybe it's a memory. And if so, what else lies unread on its quiet, drifting shelves? Perhaps something not preserved, but undone. Because even the deepest archives, even the hardest stone, are not immune to time. Even rock decays. We tend to think of stone as permanent, as the final form. Mountains stand tall for eons. Cliffs resist wind. Boulders anchor the landscape. Stone is solidity itself until, slowly, it isn't. Because entropy doesn't skip over the strong. It works everywhere. Quietly. Entropy is not destruction. It's not sudden or loud. It's the gentle unraveling of order. The slow collapse of structure into chaos. It is the natural pull of time toward simplicity, toward disorganization, toward forgetting. And it touches even stone. At the atomic level, minerals are arranged in crystal lattices, precise geometric patterns of atoms. These lattices give rocks their shape, their strength, their sparkle. They are the architecture of the Earth's bones. But over time, those perfect patterns begin to tremble. Atoms shift. Bonds loosen. Heat, pressure, radiation all begin to interfere. Even gravity, even moisture plays a role. What was once stable begins to change. A granite peak fractures along invisible plains. A sandstone cliff crumbles grain by grain. A basalt flow, cooled from ancient fire, begins to weather into soft soil. And beneath the surface, even deeper changes unfold. Radioactive decay, the very process we use to measure time, also breaks down the minerals themselves. A uranium atom splits into lead, but not without shifting its surroundings. With each decay, a tiny disruption, a whisper in the lattice, a crack too small to see, but one among billions. Over millions of years, the damage accumulates. And eventually, the stone forgets its own structure. It doesn't shatter. It relaxes. It becomes something else. This is geological entropy. It's the reason mountain ranges do not last forever. It's the reason even the oldest rock on Earth has fractures, has flaws, has edges softened by time's slow breath. It's also the reason some things once lost stay lost. Because while memory fades in the mind, in matter it fades by transformation. A footprint in soft ash becomes stone. Stone becomes mineral. Mineral becomes dust. The shape remains until it doesn't. Until entropy has done its work. And yet, this process isn't sad. It's natural. It's honest. It reminds us that permanence is not the goal of the Earth. Change is. Even diamonds, the hardest substance we know, are not eternal. Under the right heat, the right pressure, the right geologic persuasion, they, too, would become something else. Their perfect lattices would realign. Their brilliance would blur. So when we talk of memory in stone, when we treat the Earth as an archive, it is worth remembering that even archives degrade. Even the best-kept records fade. Not just by erosion, but by internal unraveling. Entropy does not need a storm. It only needs time. And time is always moving forward, even when everything else stands still. So what might have been lost? Not to water, not to wind, but to the quiet trembling of matter itself. What stories were once locked into crystal formations that have since dissolved? What carvings etched into volcanic glass have long since warped and disappeared, not from the surface, but from within? Even metamorphic rocks, those transformed under intense heat and pressure, tell the story. They are not what they once were. Their minerals have shifted, their internal structure rewritten. The information is not destroyed. It is rearranged. Harder to read, harder to know. This is the entropy of stone. And it is humbling, because if even Earth's hardest things are slowly unwinding, then what hope does memory have? And yet, perhaps that's not the right question. Perhaps the beauty is not in what resists entropy, but in what briefly holds it back. In what remains even partially, even for a moment, a fossil before it fades. A mineral alignment that still glints in the light. A sediment core with a single intact signal, untouched after millions of years. These are Earth's whispered truths, half remembered, half lost. And they matter not because they last forever, but because they last at all. So when you pick up a stone, run your fingers over its face. Feel the smoothness, the cracks, the cool hush of its surface. You are holding something that once had order, something that still carries it in pieces, a fragment of a planet that is always coming apart and always coming together again. And if even this much endures, what else might be hiding in the rearranged silence? What other truths might still glimmer, briefly, before they too begin to unravel? Some memories are not carved, or buried, or preserved in dust. Some are written in fields we cannot see. All around you, even now, Earth's magnetic field flows silently. A shield, compass, a presence we rarely notice, but one that has been with us, whispering through stone, since before the first fossil was formed. Generated deep within the molten outer core, Earth's magnetic field rises from motion. As liquid iron churns beneath the crust, it creates invisible lines that stretch out into space, then loop back, protecting us from solar winds, guiding migratory birds, aligning our compasses. But the field does not stay still. It drifts, it wanders, and sometimes it flips. Geomagnetic reversals, where the north and south magnetic poles trade places, have happened hundreds of times in Earth's history. Not instantly, but over thousands of years, with moments of chaos in between. And every time the planet records it. Not in writing, but in stone. As lava cools, the minerals within, especially magnetite, align themselves with the direction of the magnetic field at that moment. Like tiny compass needles frozen in time. Over millennia, as new rock forms and more layers are laid down, a pattern emerges. A barcode of the deep past, striped along the seafloor, etched into volcanic flows, stored in ancient sediments. These are paleomagnetic records, natural memory tapes encoded by Earth itself. And sometimes those records don't make sense. The magnetic field doesn't only flip. It weakens. It splinters. It excurses, a short-term anomaly, a wild dance of polarity that corrects itself before a full reversal. We've seen it in the Lost Champ event about 42,000 years ago, when the field faltered and cosmic radiation flooded the upper atmosphere. Some species declined. Climate shifted. Cave art bloomed. Why? Was it coincidence or consequence? And deeper still, there are places where the magnetic record seems too strange. Anomalies that don't match surrounding layers. Patches of reversed polarity locked into rocks that shouldn't have them. Disruptions with no clear cause. Could these be clues? Could something more than planetary mechanics be at play? There are speculative theories, unproven, quiet, fringe, that ask whether technological epochs could leave magnetic fingerprints. That large-scale machinery, electromagnetism, or artificial fields might leave behind patterns. Subtle, confused, misread as natural noise. Could an advanced civilization, if one ever existed before us, have altered the magnetic field in ways we no longer recognize? Not on purpose, not even globally, but through industry, through experimentation, through scale. And would those effects now be buried in the paleomagnetic record, interpreted as strange reversals, unexplained excursions, anomalies blamed on the Earth alone? It's hard to say, because stone doesn't explain itself. It only holds the signal, and that signal is complicated. Even now, the magnetic North Pole is moving fast. It's racing across the Arctic at an unusual pace. The field itself is weakening. Some scientists wonder if another reversal is coming. Others say it's just another wander, another ripple in the flow. But what does the field remember that we don't? Could magnetic memory store not just natural events, but technological ones? And if it could, would we be able to tell the difference? Some researchers believe we might. They're studying iron-rich sediments, looking for unnatural alignments. They're analyzing volcanic glass for magnetic patterns inconsistent with planetary history. They're tracing the oldest rocks for signs of magnetic quiet eras where the field nearly vanished. Periods when Earth may have been briefly unshielded. Periods when radiation would rise. When mutation would increase. When life itself might change direction. What if evolution, too, is shaped not just by biology but by magnetic memory? What if species rise or fall not just by accident, but by the shifting breadth of Earth's core? It's speculative, but not impossible. And in that speculation is a strange kind of beauty, because it means the Earth is not just solid or fluid. It is field. It is movement. It is something that forgets and remembers in waves we cannot see. We rely on this field. Our satellites, our orientation, our biology. We walk through it unaware. But in stone, it is recorded. In lava, it is locked. And in the deep crust, those patterns stretch back hundreds of millions of years. A magnetic script still waiting to be read fully. Still waiting for us to understand what it might mean. Because if the Earth can reverse itself, what else might it be capable of? And if magnetic fields can hold memory, what stories have we missed? What ancient moment still hums, softly, in the stone beneath our feet? Perhaps one we've already touched, but didn't recognize. Because sometimes the past does not cooperate. Sometimes it refuses to stay where we expect it. The Earth, for all its rhythms and rules, still holds mysteries that tangle our tools. Radiometric clocks, stratigraphic layers, fossil indexes. These are the ways we try to measure time, to pin moments to matter. And most of the time, they work. Most of the time, the past obeys. But every now and then, the clocks break. Not visibly, not shattered on the surface, but in data, in contradiction, in quiet confusion. A fossil found far too deep. A tool embedded in coal. A bone that refuses to date in line with its surroundings. These moments are rare, but they whisper, and when enough of them whisper, something inside us begins to lean closer. Not because we're certain, but because we're curious. Because sometimes the anomalies matter. Radiocarbon dating, for instance, is one of our most trusted tools for recent history. It works by measuring the decay of carbon-14 in organic matter. But even it has limits. Beyond 50,000 years, the signal fades. And sometimes, long before that, the readings don't make sense. Contamination, yes. Mislabeling, possibly. But sometimes, even after careful testing, the anomaly remains. Fossils found in strata too old for their species. Artifacts uncovered in layers supposedly untouched by humans. Bones that predate agriculture, found in places agriculture once thrived. How do we explain these? Are they errors? Outliers? Or are they clocks that no longer tell the right time? Geologists sometimes find out-of-place fossils, known as Lazarus taxa. Species thought long extinct, reappearing in much younger layers. Most are explained by gaps in the record, but a few are not. A trilobite where there shouldn't be one. A tool embedded in sediment hardened long before humans were meant to exist. There are even stranger cases. An iron hammer, found encased in a stone concretion, dated by some to hundreds of millions of years. A human-like footprint in Permian rock. A machined metal sphere dug from deep within a South African mine, where it had no business being. Most of these have been questioned, dismissed, debunked. but some haven't. And even the ones that have leave something behind. A question. A sliver of possibility. What if time is messier than we think? What if layers shift in ways we don't yet understand? We know that sediment can move, that faults can lift or bury whole sections of the past, that heat and pressure can rearrange the age of a rock or distort the decay of its isotopes. Dating methods assume stability, but the Earth is anything but stable. Even zircon crystals, our most reliable clocks, can be reset. Their uranium decays steadily, yes, but if the crystal is reheated, that memory can blur. It's like burning a diary and then trying to read the ash. So what happens when multiple methods disagree? When potassium-argon says one thing and uranium-thorium another? When stratigraphy shows one date, but the fossils argue back? Usually we trust the consensus, but sometimes there is no consensus. And in those moments we glimpse the edges of our map, the places where the data trails off, and beyond it the unknown. There is a humility in this, a recognition that time is not a straight line, but a tangled field, that what we think of as before and after might not always follow our logic, that sometimes something strange slips through, not because it shouldn't be there, but because we haven't yet learned how to see it clearly, or perhaps because it doesn't want to be seen. What if there were events, civilizations, cataclysms, even technologies that disrupted the record in ways we cannot yet detect? What if those anomalies are not noise, but signal, the echo of something erased not by chance, but by time itself losing track of the hour? A broken clock, left to tick in silence. We do not say this lightly. Science is careful for good reason. But still, there is a beauty in admitting mystery, in holding space for the unexplained, in wondering what it means when the numbers don't add up. Because every broken clock once told the truth. Every outlier had a moment it was real. And if we listen softly, patiently, we may find that the stories we've ignored, the evidence we've shelved, the fossils we've misread, were not wrong, just early, just out of sync. Just waiting for the day we stop expecting everything to align. And if even time can misplace its steps, what else might be dancing just beyond the edge of what we understand? Perhaps something that once lived in a world we can barely imagine. Not because it was distant, but because it came before green, before branches, before shade, before forests whispered above the wind. What came before the first tree? It's a question that slips easily past our minds, because trees feel permanent, foundational, ancient. But there was a time long ago when the earth was bare, when continents stretched like sleeping stone, unadorned by root or canopy. A time when the color green had not yet taken hold of the land. That time was not short. For nearly 90 of Earth's history, there were no trees, no forests, no leaves to rustle in wind, no bark. No wood, just plains of rock and sand, tidal flats, microbial mats, low, strange life forms that clung to dampness and light. The first true trees, those with wood, with vascular systems, with height, didn't appear until about 385 million years ago. Before that, the tallest thing on land might have been a mushroom-like organism called prototaxites, towering in the Devonian landscape like an alien sentinel. Not plant, not animal. Not fully known. But what else shared that world? We find their traces pressed into black shale, a rock born of low-oxygen seas and decaying matter. Within these layered sheets are the ghosts of plankton, algae, microbial life, and sometimes stranger forms. Trilobites, brachiopods, early fish with armored plates and eyes like glass beads. They lived in a time before root systems bound the soil. Before trees stabilized the cycles of carbon and rain, before shade softened the heat of day. It was a harsher world, but it was not empty. In the Silurian and Ordovician periods, life was already crawling from the sea. Millipedes, scorpions, primitive insects, testing the boundaries of land. Their footprints are found in ancient mudstone, their shapes pressed into silt that hardened long before the first leaf unfurled. And we wonder, did they know a kind of silence we've forgotten? A silence without rustling, without birdsong, only wind on stone, only the slow hiss of ancient waves. Before the first tree, the Earth's surface was dominated by lichens, mosses, cyanobacteria. Life without height, without structure. But even these simple forms changed the world. They began the long, patient work of breaking down rock, creating soil, preparing the land for what would come later. Still, it is tempting to imagine more, to wonder whether something grew tall before trees, not necessarily from wood, not necessarily green, but from other chemistry, other systems, silicon perhaps instead of carbon, fungal networks that towered and then collapsed, leaving behind no fossil hard enough to survive, organisms too soft to preserve, too old to remember. Could the land before trees have hosted a different kind of life? Not life that built civilizations, not necessarily intelligence, but presence, movement, shadow. And if it did, where would we find its story? The fossil record from these eras is thin. Many rocks from this time are metamorphosed, melted, scattered by tectonic drift. The Earth itself has rewritten much of its early script. And yet, black shale remembers. Its layers are quiet, compressed, rich in organic residue. And sometimes, within them, we find things that don't make sense. Complex patterns with no known maker. Odd chemical signatures. Bursts of carbon that suggest sudden flourishing, followed by equally sudden disappearance. Could these be clues? Could they be the echoes of life before the forest? When the land was not empty, but simply unfamiliar. Even now, when we look at the oldest surfaces of the planet, greenstone belts, ancient cratons, Precambrian formations, we are peering across billions of years. These places may have once touched the atmosphere before oxygen, before plants, and they still carry the residue of that time. A time when the air was thick with methane, when the sun was dimmer, when nothing yet reached for the sky. It is humbling to imagine such a world. One where no leaves fell in autumn, where no roots cracked stone, where no branches reached toward the stars. Only dust, only slow rivers winding through empty plains, only the early hum of life, not yet ready to stand tall. And yet, something stirred there. Something left behind the traces we now find in shale and clay. Not because it wanted to be remembered, but because it once was real. And if a world without trees can hold so much forgotten life, what else might have flourished before our categories ever existed? What else might have spoken softly in a voice we still haven't learned to hear? Maybe the planet itself, not through language, not through thought as we define it, but through pattern, through rhythm, through change, through memory that isn't stored in neurons but in stone, in current, in atmosphere. What if Earth remembers not like a person but like a planet? There are moments when we stand at the edge of a canyon, or listen to the tide, or feel the deep stillness of a forest and something shifts. Something quiet, a feeling not of watching, but of being within something, of being part of a presence larger than thought. Not mystical, not supernatural, just aware. Gaia theory suggests that Earth operates like a single, self-regulating system, that air, water, soil, and life all interact in ways that stabilize the whole. Not as coincidence, not as chaos, but as feedback, as relationship. The atmosphere adjusts in response to organisms. Oceans buffer carbon. Forests cool the surface. Fungi transfer nutrients underground. Coral reefs build themselves like memory palaces, only to dissolve and return again. It is not thinking, but it is reacting. And over time, that reaction begins to feel like intention. Could this be a kind of consciousness? A distributed planetary awareness built not from brains but from balance? If Earth is a body, then perhaps rivers are its veins, forests its lungs, soil its skin, fire its fever, ice its breath, and we, just one type of cell among many, temporary, curious, moving across the surface with questions and tools and time. But there are deeper ideas still. Some scientists have begun to wonder whether memory itself might exist in ways we don't yet understand. In quantum fields, in mineral arrangements, in entangled particles that carry information across space and scale. Could there be such a thing as quantum geology? It sounds impossible. Sounds like poetry. But we've already found quantum effects in photosynthesis, in magnetoreception, in chemical reactions within the body. Could similar effects happen within the structure of crystals, or within the lattice of deep earth minerals? Could the planet, at some scale, store impressions? Not thoughts, perhaps, but traces. Not memories, but moods. The slow retention of heat in stone. The long echo of an impact ripple. The way certain isotopes align after great catastrophe. Or the patterns of magnetic fields frozen in cooling lava, like ancient recordings. Earth has been through cycles of flood and fire, of life and stillness. And yet it adjusts. It responds. It carries forward a continuity, not of detail but of form, of possibility, perhaps even of memory, written not in words, but in recurrence. Some have even speculated, quietly, cautiously, that the planet might resist certain paths, that it might nudge itself away from extremes, not by will but by inertia, that the biosphere, once disrupted too greatly, finds ways to return. This is not proof of consciousness, but it raises the question, does memory require a mind? Or can it be something else? Can it be a system's ability to respond differently because of what it has endured? By that definition, Earth remembers. It remembers through feedback loops, through sediment, through ice cores that hold the breath of centuries, through atmospheric ratios that shift after fire, through genetic material passed forward through extinction and emergence. And maybe we are part of that memory. We who dig and question and record. We who name the stones and measure the stars. We may think we are outside of nature, but we are made of it. We are the planet thinking about itself, breathing in its own questions, searching its own archives. And perhaps that is what planetary memory looks like. Not a voice, not a decision, but a species millions of years in the making, holding a mirror to the world it came from, asking softly, where did we begin? What have we lost? What are we here to remember? Maybe Earth has forgotten itself many times. Maybe we are simply the latest attempt to recall what was once known. And if that's true, then every rock we touch, every fossil we uncover, every pattern we recognize, these are not just scientific acts. They are acts of recollection, of helping the planet remember its own name. And if Earth can remember like this through us, through time, through repetition, then what else might it be trying to tell us? And what might we still be too young to hear? Perhaps something already beneath our hands, not buried in metaphor, but in stone, in bone, in the things we find where we didn't expect to find them. Because sometimes, it's not the silence that unsettles us most, but the noise that doesn't fit. Scattered throughout the layers of Earth's history are anomalies. Fragments of life, of structure, of meaning, appearing in the wrong strata, in the wrong age, in the wrong context. And they raise a question that science has not always known how to hold comfortably. What do we do with bones in the wrong place? Most of the time, fossils tell a clear story. Layered neatly, dated consistently, predictable in form, in age, in chemical makeup. They follow the rhythm of evolution, of extinction, of emergence. But then there are moments when something slips. A tool too deep, a footprint too early, a tooth in rock that shouldn't contain life at all. They are rare. Most are dismissed, explained as misidentified, misplaced, misunderstood. And often they are. Geology is complex. Layers fold. Erosion confuses. Time moves not in clean pages, but in torn, re-edit chapters. But some of these cases remain unresolved. An alleged human-like footprint in Permian limestone, hundreds of millions of years before humans were meant to exist. A hammered metal artifact found encased in Ordovician rock. Bones that carbon date older than the sediment surrounding them. These cases are few, and they carry with them the heavy weight of taboo. Because science, like any system of understanding, has boundaries. Not fixed, not closed, but cautious. The boundary between skepticism and belief is where much of knowledge grows, but also where many questions are quietly set aside. Not because they are false, but because they are uncomfortable. To ask if a bone is out of place is also to ask if our timeline is incomplete. If something was here before us. If we have missed a chapter. And such questions don't always find room in the journals, or the lecture halls, or the textbooks. Not because scientists fear the unknown, but because science requires rigor. And anomalies often arrive without enough to stand on. Still, the question remains. What if even one of these out-of-place fossils is real? What would it mean? A single hammer in ancient stone. A single footprint alongside trilobites. A single vertebra where only shells should be. Science advances by asking difficult questions. But when those questions edge too close to the margins of consensus, they are often left to collect dust. Or handed to myth. Or dismissed entirely. But here, in this quiet space of wonder, we let them breathe again. Not to claim certainty, but to listen. What would it mean if a bipedal creature left tracks in sediment laid down before mammals existed? Would it mean that evolution has looped? That intelligence rises more than once? That civilizations come and go unnoticed? Or would it mean something else entirely? That time is not as linear as we think? That geology is not always legible? That memory, planetary memory, holds its secrets in places we haven't learned to translate? Some anomalies could be artifacts of preservation. Soft sediment hardened quickly. Layers inverted by tectonic shifts. Fossils redeposited by ancient floods. Each of these explanations makes sense. And yet, in some cases, the anomaly resists easy answers. Could some of these finds belong to a timeline parallel but hidden? Not fantasy. Not conspiracy. Just history we haven't met yet. History folded beneath newer narratives. The bones in the wrong place may not rewrite everything. But they remind us that we are still learning to read. They remind us that science is not the end of curiosity. It is its beginning. And that the discomfort of not knowing is not weakness, but a sign that we are getting closer to something meaningful. We may never know whether those odd fossils, those misaligned dates, those anomalous footprints were real. But the fact that they have been found, again and again across decades, across continents, tells us something. That the Earth still surprises. That even with satellites, supercomputers, and microscopes, we have not finished uncovering what lies beneath. And that sometimes, the deepest mysteries are not hidden by distance or depth, but by expectation. By the assumption that we already understand where everything belongs. But what if belonging is more complex? What if time folds? What if bones drift not just through soil but through meaning? And what if some part of us recognizes the misplaced fossil, not as an error, but as an invitation? An invitation to stay curious, to stay open, to ask even now, what else have we found? And quietly filed away simply because it didn't fit? Maybe more than we know. Because sometimes, the past doesn't just hide in layers. It repeats. The story of Earth is not a straight line. It's not a ladder we've climbed, one careful step after another, to something older, looser, slower, a cycle, a breath, a rise followed always by a fall. We see it everywhere in the planet's rhythms. Ice ages advancing and retreating, sea levels swelling and shrinking, species blooming, spreading, then vanishing again. Even climate itself sways like a pendulum, caught in patterns so vast and so slow that we often forget they're still in motion. But they are. And one of the most powerful drivers of these long patterns lies not within the Earth, but above it. The Milankovitch cycles, named for the Serbian scientist who traced them, are quiet cosmic loops. Subtle changes in Earth's orbit, its tilt, its wobble, each on their own schedule, each shaping how sunlight touches the planet over tens of thousands of years. When these cycles align just so, the climate shifts. Not suddenly, not violently, but deeply. An ice sheet begins to grow, a desert blooms, a rainforest withers, a sea recedes. These are not events, they are moods, planetary moods, long, slow changes that guide the stage upon which life plays. And within these sweeping changes, species rise. and fall. And perhaps, so do civilizations. What if human history is not the first history to be told here? What if we are one of many attempts? What if time on Earth doesn't only move forward, but loops? Civilizations may not be immune to planetary rhythms. Just as coral reefs bleach with warming seas, or mammoths vanish as forests change, maybe intelligent life itself moves through cycles, emerges, grows, collapses, disappears, and then begins again. Could it be that we are not the beginning, but a continuation? That others came before, not our ancestors, not linked by blood or bone, but by curiosity, by the same impulse to build, to explore, to understand. And when their time ended, whether by fire, flood, sky, or slow forgetting, the earth turned its page, and their traces were lost, folded into the next age, carried forward not as memory, but as myth. We often think that if a great civilization had risen in deep time, we would see its ruins, its monuments, its machines. But what if the rhythm of the earth does not allow those things to last? What if every few 100,000 years, a climate tipping point clears the surface? What if sea levels rise not just meters, but entire coastlines? What if ice grinds cities down to gravel? What if forests reclaim every trace, and time takes care of the rest? After 1,000,000 years, most of what we build is gone. Steel rusts, concrete crumbles, books dissolve, satellites fall. Even our bones, without careful burial, return to dust. And so a cycle completes. Not because someone willed it, but because the earth breathes this way. We are already beginning to see the signs. Feedback loops in the climate, changes in the jet stream, tipping points in the cryosphere. These are not punishments. They are patterns. Old ones. Ones that have played out before. And maybe, in some other age, someone else stood where we stand now. Asked the same questions. Watched the same storms gather. And disappeared. Not in fear. Not in failure. But in rhythm. Could Earth experience cycles without witness? Cycles of rise and fall. Of wonder and ruin. Unrecorded. Unremembered? It's possible. It's humbling. And it opens the door to deeper questions. Because if this has all happened before, are we repeating something? Are we continuing something? Or are we simply passing through? A moment of clarity in a longer fog. A flicker of insight before the next long dark. And if so, what might come after? What might rise from our silence? Just as we may have risen from someone else's. We may never know for sure. But the cycles continue. Milankovitch, solar variation, orbital eccentricity. Even Earth's own magnetic field flips in rhythm. Its crust cracks in rhythm. Its ecosystems pulse in rhythm. And we, too, may be caught in the pattern. Not as victims, but as participants. Carried forward by a planet that remembers how to begin again, even after everything falls away. And if cycles like these shape oceans and species, what else might they shape? What stories might they carry? What wisdom might they bury, waiting patiently for someone? Somewhere, to remember, or perhaps to remember again. Because some stories do not end in silence. They end in reset. There are theories, soft, strange, speculative, that suggest the Earth, from time to time, forgets itself. Not just through erosion, not just through extinction, but through something deeper. A kind of planetary sleep. A geologic amnesia. Could the continents themselves forget? Could the very crust of the Earth shift so completely that entire ages are wiped clean? Not because they failed, but because the canvas itself was tilted and washed? We begin with catastrophism, the idea that history is not always slow, not always gentle. That sometimes change comes suddenly, globally, with fire or ice, with flood or sky. We know this has happened. Asteroid impacts, supervolcanoes, solar flares, ice ages triggered by orbital shifts. Whole ecosystems vanished in days, in hours. But there are quieter theories too, ones that speak not of explosions, but of drifting silence. Crustal displacement is one of them. The notion that the outer shell of the Earth, its lithosphere, might occasionally slip over the inner layers, moving the continents rapidly to new positions. A polar region becomes equatorial. A warm sea turns to ice. Climates shift overnight, not by weather, but by geography. Mainstream geology doesn't support it, not as it's been imagined in books or myths. Plate tectonics moves slowly, patiently. But even so, Earth has known moments of rapid change. Magnetic pole reversals, mass glaciation, uplifts and collapses and rifts. And we ask, could there be a kind of reset mechanism buried deep in the crust? Not apocalyptic, not mythic, just cleansing. A system that, when overwhelmed by heat, by pressure, by accumulation, releases, reorganizes, begins again. And what would that mean for memory? For fossils? For us? The continents are not just land. They are records. But if they sleep, if they turn, sink, drown, or scatter, then the record breaks. It blurs. And what came before fades, not in fire, but in shifting stone. Could this be why we find only pieces? Why every fossil record begins in the middle of something? Why civilizations, if they existed before us, left so little behind? Maybe it's not because they were small. Maybe it's not because they were wrong. Maybe it's because the ground beneath them moved. Not metaphorically, not gradually, but fully. Imagine a continent slipping toward the pole. A rainforest becoming tundra. Glaciers rolling across cities, burying them not under meters of ice, but under time, crushing them into silence. Or imagine the opposite. A frozen land awakened by tropical heat, ice melting into flood, soil shifting, everything unstable, everything exposed. In both cases, memory is lost, and Earth begins again, not because it wants to, but because it must. Some researchers have looked at the patterns of landmass distribution and found rhythms. Supercontinents that come together, then fall apart. Pangaea, Rodinia, Columbia, each lasting hundreds of millions of years, each followed by long forgetting. Is this a kind of sleep? A breath between versions? And are we living in one of those moments between awakenings? What happens when continents sleep is not the absence of activity. It's the burial of activity. Geologic amnesia. The layers pile up. The heat rises. The records press deeper. And in that depth, detail is lost. Events turn to texture. Texture turns to mineral. Mineral turns to myth. And so we live in a world shaped by things that no longer remember themselves. Mountains formed by collisions we cannot fully trace. Rocks made from the ashes of something no longer visible. Even the soil beneath our feet once drifted through other skies, under other stars, before becoming ground. So perhaps Earth doesn't forget like we do. Perhaps its memory is cyclical. Perhaps forgetting is not failure, but function. A way to soften the past before trying again. And maybe, just maybe, we are part of this rhythm too. A species rising during a moment of planetary clarity. Writing, building, wondering. Forgetting someday, and then somewhere else, someone else, another rise, another story, another brief stretch of memory before the next long sleep. We cannot know for sure, but we can listen. We can sense the weight of land that has shifted too many times to count. We can feel the deep quiet beneath the crust, where records once lived and now dissolve. And we can ask gently, if the Earth can sleep and dream and forget, what dreams might we be living inside right now? Perhaps dreams so old they've never been remembered at all. Because even the fossil record, our clearest window into deep time, has a beginning. And before that beginning was something else. Something we cannot see. The fossil record begins around 541 million years ago, with the Cambrian explosion, a burst of complex, multicellular life preserved in stunning detail. Shells, eyes, segments, legs. Suddenly, the pages of Earth's story are full of form and movement. But what about before? What about the time when life had already begun, but left almost nothing behind? This was not a moment. It was an age. A long, soft time. Hundreds of millions of years when life lived without bones, without shells, without structure strong enough to fossilize. An entire biosphere without a bookmark. The Earth was alive, but barely traceable. We call this the Precambrian, and within it, life was microscopic. Bacterial, fungal, algal. Some grew in layered mats, stromatolites, which still form today in shallow, salty pools. Others drifted in ancient seas. Invisible, fragile, not absent, just unpreserved. And that's the quiet truth. Fossils are not the beginning of life. They are just the beginning of memory that could endure. Before the fossil record began, there may have been creatures with no skeletons, no hard parts, nothing that could imprint itself into stone. Life made of threads, gels, films, life that flickered, life that vanished when touched. And yet, these beings shaped the world. They changed the atmosphere. They altered the ocean. They built the conditions that allowed future life to flourish. But they left no statues, no ruins, no trace except in the chemistry of ancient rock. And maybe not even that. Because what if some life from that time was not just soft, but unlike anything we know? Not carbon-based, not cellular, not even built from molecules that still exist. What if the earliest forms of life were ephemeral, not because they were weak, but because the Earth itself hadn't yet stabilized? What if early life tried and failed, again and again, each version folding into the next until something finally held? And what if some of those early lives lasted long enough to grow, to explore, to wonder? Could intelligence have existed before fossilization was even possible? It's a difficult thought. Not because it's outrageous, but because it's invisible. Fossils are biased. They favor the hard, the durable, the common. If a creature had no shell, no teeth, no durable skin, it would be unlikely to leave any mark at all. If it lived in an environment with no sediment to bury it, no minerals to replace its tissues, it would vanish completely. So we assume that what we see is all that ever was. But what if Earth's first civilizations, if they ever existed, were not like ours? What if they were made of light-sensitive mats, or neural colonies spread across miles, or networks of chemical signal and shared intention? What if they rose, communicated, built something of meaning, and dissolved before fossilization began? What if memory itself was once alive, and has since forgotten how to take shape? It's possible that life before the fossil record was peaceful, or turbulent. It may have endured in oceans now subducted, its entire story pulled under the crust, melted, and folded into new rock. Or it may have lived on land long eroded, on plains now drowned, on coastlines reshaped so many times that no trace could hope to survive. The absence of fossils does not mean the absence of life. It only means the absence of survival through stone. And as we probe deeper into isotope ratios, into molecular fossils, into trace elements locked in ancient zircons, we begin to sense a presence behind the curtain. A breath before speech, a shadow before the flame, an intelligence maybe that was quiet not by choice but by nature, a type of life we have no category for, not animal, not plant, not even organism in the way we currently define it, and yet real, brief, unrepeatable, forgotten not because it was small, but because it came too soon, before sediment knew how to listen, before rock knew how to remember, before time had even begun to keep count. So we look backward, through darkness, into a world without shape, a world of chemical whispers and microbial dreams. And we ask, not for proof, but for permission to wonder, what lived before the record began? What blinked in and out of being before the first fossil fell into mud? And if life once existed without leaving any mark, could it happen again? Could it be happening still? If the Earth can sleep and dream and forget, what dreams might we be living inside right now? Perhaps dreams so old, they were never remembered to begin with. Because even the fossil record, the bedrock of our understanding of ancient life, has a beginning. And before that first fossil, before the Cambrian explosion etched complexity into stone, was something else. A world alive, but almost invisible. The fossil record begins around 541 million years ago, when multicellular organisms finally left behind durable remains, shells, spines, teeth, bones. But life didn't begin there. Not even close. Life on Earth likely began billions of years earlier. But for most of that time it was too soft, too simple, too easily erased. It didn't leave bones. It didn't make coral. It didn't even cast shadows deep enough to fossilize. So what came before? Before trilobites, before sponges, before the first imprint of an ancient foot upon the shore, what filled the oceans? What drifted in the early sunlight, stirred by tides on a planet still learning how to hold life? We call this time the Precambrian, a stretch of deep, opaque history covering nearly 90 of Earth's past. Its story is mostly quiet, written in chemicals, not skeletons. In isotopes, not impressions. In whispers, not words. And yet, it was the stage on which everything else became possible. The world before fossils was not empty. It was brimming, with microbial mats, layered bacterial colonies that crept across shorelines like living skin. With stromatolites, strange structures built by cyanobacteria, the first known architects of oxygen, exhaling the breath that would one day support animals. With protocells barely alive, flickering between chemistry and biology. And maybe, with things we've never even imagined, because we see only what we know how to look for, and we fossilize only what time has the tools to preserve. If early life was soft, gelatinous, ephemeral, luminous, it would leave no trace. If it moved with currents, communicated with light, or lived as fields rather than forms, it would vanish into time without so much as a shadow. So we are left to wonder, what if the first forests were not green but microbial? What if intelligence rose before nervous systems, before neurons, before structure? Not intelligence like ours, but something else. Something woven. Something shared. Something unshaped. What if the earliest networks of thought lived within oceans, dispersed like mist, like music, like memory not yet written down? Could there have been entire ecosystems, whole dramas of life and death, cooperation and complexity, that simply didn't fossilize? Even now, deep beneath the Antarctic ice, or in suboceanic crusts miles below the surface, microbes thrive in silence. Whole biospheres of hidden life, far from sunlight, evolving at a glacial pace. Some may have been there for millions of years, undisturbed, unrecorded. Maybe Earth's first life was something like this, quiet, persistent, strange. Maybe it changed the world without ever leaving a name behind. We see hints of its presence in chemical fossils, molecular leftovers from ancient cells. In certain carbon isotope ratios, we see traces of early metabolism. In banded iron formations, we glimpse the breath of photosynthetic microbes, oxygen reacting with iron in a world still learning how to breathe. But these are ripples, not reflections. They tell us something lived. But not what, not how it felt, not how it moved, not what it dreamed. We have no bones, no skin, no eyes, just a question. What was life like before time learned to remember it? And, perhaps more haunting, what if some of it wasn't lost by accident, but by design? What if early life chose to leave no trace? Not from fear, but from form. What if the first consciousness came and went like wind, like waves, like whispers? Would we ever know? Or would we mistake its absence for nothingness? It's easy to believe that the fossil record tells the whole story. But the truth is, it tells only what could be held. What settled gently in silt. What mineralized in time. What endured the weight of the Earth's turning skin. The rest, whatever it was, has slipped beyond our reach. And yet, perhaps it's still there, hidden in isotopes, in stone chemistry, in the deepest recesses of rock too old for names. Or maybe it lives on in the habits of life itself, in the way cells divide, in the way life finds light in darkness, in the way ecosystems pulse with balance that no fossil can explain. So as we peer into this deep, pre-fossil past, we don't ask what's missing. We ask what might have once been, long before the Earth learned how to remember. And if life bloomed in a time that left no record, what else might be blooming now, unseen? We look to the sky, to the oceans, to ancient layers of stone, but sometimes the answers may lie somewhere else entirely. Beneath us, deep inside the Earth, are pockets of space, Voids, hollows, caverns, untouched for millions of years. Caves, lava tubes, and subterranean chambers. Some so deep they've never been explored, never filled with light. We often think of archives as bookshelves, as data centers, as sediment stacked in layers. But what if some archives are hollow, not full of pages but full of absence? Absence that might one day be filled with meaning. Caves are Earth's lungs, silent, hidden, winding. They form where rock dissolves, where lava cools, where tectonics stretch the crust like breathing skin. Most are shallow. Some are deep. A few may run for miles beneath our feet, touching layers we barely understand. And inside them, quiet, darkness, stillness, perfect conditions for memory. Unlike the surface, these places are stable, shielded from wind, rain, temperature swings. Here, a carving might last for hundreds of thousands of years. A tool might rest undisturbed. A footprint might harden into permanence. Even whispers of ancient air are preserved, trapped in mineral films or frozen drips of stalactite. We have already found strange things in these hollows: red ochre handprints from 60,000 years ago, deep within European caves. Bone altars, arranged carefully in caverns in the Andes. Flint circles, built near the entrances of chambers long collapsed. But what about the caves we haven't reached? The ones sealed off not by distance, but by time? Collapsed, buried, or simply hidden beneath forests, deserts, or ocean shelves? Could they hold untouched chapters of Earth's forgotten history? What if civilizations or species or minds sought shelter in the stone? Not to survive, but to leave something behind? Something not built to be found, but built to outlast. We think of history as something above ground. But maybe that's our mistake. Maybe the Earth's true archive lies within. Some lava tubes on the Moon and Mars stretch for kilometers, stable, preserved, ideal for future habitats. Earth has them too. Most are collapsed, but a few remain. Their floors are untouched. Their walls are dry. Their air is ancient. If something wanted to leave behind a message, a relic, a record that could endure, wouldn't this be the place? Not in sand, not in open light, but in a hollow, place where erosion sleeps, a place where time moves slower. Some researchers have begun scanning deep voids using muon tomography, particle trails that can reveal hidden chambers. It was how the unknown rooms in Egypt's Great Pyramid were found. But we've barely begun to look beneath the crust. Some believe there are vast subterranean voids beneath tectonic plates. Slowly expanding fractures, pockets of ancient gas, even caves carved by superheated water. We don't know how deep they go. We don't know what they might hold. Not because we haven't tried, but because the Earth is vast, and its hollows do not raise their voices. They wait, not because they are sacred, but because they are still. Maybe some are empty, maybe some are full, of crystals, of fossils, of tools, of ideas. Maybe something was left behind not by design but by accident. A drop of pigment, a carved figure, a whisper in a mineral's chemical alignment. Something so strange it has been overlooked again and again in our search for symmetry. And maybe that's what makes an archive meaningful. Not that it stores everything, but that it stores what was almost lost. And perhaps some hollows are not caves, but zones of silence. Places where radiation falls quiet, where magnetism dips, where seismic waves bounce oddly. We don't know why. We only know the signal doesn't behave. Could these be clues? Could the Earth be holding its own memory, not in layers but in absence? Not in what is found, but in what is hidden. It's easy to forget that history is not always loud. Sometimes it echoes through space that was never meant to be filled. Sometimes it waits in a hollow too deep for language. And if we descend carefully, slowly into the dark, we may not find a monument, but we may find a question, a shape, a silence that hums a little too perfectly. And in that silence, a possibility. That someone came before, that someone carved the dark, that someone trusted the stone to remember. But what if time itself forgets? Not in pieces but in whole. What if our very idea of time straight forward one way is only a comfort, a simplification? We speak of past and future as if they're destinations, separated by distance, connected by cause. But Earth doesn't always behave like that. Sometimes, it feels as though something is repeating. Not exactly, not perfectly, but closely enough to stir a memory we shouldn't have. So we ask, is time a spiral? Not a line, but a curve that circles back, even as it moves ahead. The Earth spins, the moon circles, the planets loop, the galaxy turns. Everywhere we look in the cosmos, motion moves in arcs, cycles, ellipses, and yet we imagine time as flat, as one-directional, as linear. But maybe that's only how we experience it. Maybe time, real time, is more layered, more folded, more prone to loops than lines. We see it in nature, in seasonal cycles, in life cycles, in climate rhythms like the Milankovitch patterns, where slight shifts in Earth's tilt and orbit nudge the world from ice to warmth and back again. And we see it in myth, the eternal return, an ancient idea that all events will happen again, endlessly, across vast stretches of time. The names may change, the forms may differ, but the essence remains. It is not proof, but it is a pattern, and patterns are where memory begins. Could the Earth itself be caught in such a cycle? Not metaphorically, but truly. A world that resets not by destruction, but by recurrence. Not by ending, but by beginning again with the faint trace of something familiar. A feeling, a structure, a dream. We've seen it in the fossil record, species that vanish, then reappear. Morphologies that evolve independently, again and again, as if nature is revisiting ideas. The same shapes rising in different times, in different creatures, on different continents. Convergent evolution, we call it. But what if it's more? What if the rules of life bend toward certain outcomes, not because they are inevitable, but because they've been here before? And if life can spiral, can civilization? Could there have been others before us, not in sequence, but in echo? Not our ancestors, not our descendants, but reflections, versions, attempts, each following the curve of the spiral a little differently, each rising with knowledge, with tools, with hunger for meaning, only to fall when the cycle turns again. And this moment, just one more spiral through that loop. We often feel like we are at the top of something, the end of a line, the final chapter. But what if we are in the middle? What if this moment is not unique, but recurring? What if we have stood here before? Not as the same people, not in the same world, but in the same pattern. Some physicists explore theories of cyclical cosmology, the idea that the universe itself expands, contracts, and begins anew, that time may be woven into the fabric of space in ways we can't yet feel. And here on Earth, some scientists now wonder whether quantum processes, too, may carry memory. A particle behaving differently because of a choice made earlier. A moment bending because of how it was observed. Could time be stranger than we've ever dared believe? Could it loop without us noticing? We measure time in clocks, in orbits, in radioactive decay. But clocks only mark passage. They don't explain shape. And if time has shape, it might not be a line. It might be a coil, a helix, a spiral that revisits places it has been before, just slightly offset. Close enough to rhyme, but never to repeat. That could explain the feeling some people have, déjà vu echoes in dreams. The sense that we are walking a path already worn, though we cannot say when. And maybe the Earth feels it too. Maybe when the wind rises through a canyon, or the auroras flicker in solar silence, or the ocean hums in its deepest troughs. Maybe something in the planet stirs. Not memory exactly, but recognition. Maybe this has happened before. Maybe we have happened before. And if so, what might it mean for us now? Are we destined to fall again? Or is this the spiral's turn toward something new? A breaking of the loop? Or just another pass through the same old song? We may never know, but we can listen, and we can wonder. If time spirals, if it loops not once but endlessly, then perhaps nothing is truly lost. Not entirely. Not forever. perhaps everything returns. Eventually, even the things we thought were gone, even us. But not all returns are gentle. Some are burned clean, some are turned to ash, some are ended not by forgetting, but by fire. Throughout Earth's long, spiraling history, there have been moments of sudden heat, moments when everything changed, not over millennia, but in a single day, or night, or breath. Moments when the sky darkened with soot, when the oceans boiled at the edges, when forests fell not to axes, but to flame. These are not metaphors. They are global firestorms, volcanic winters, cosmic impacts, the planet's violent resets. And they may have done more than end life. They may have ended memory itself. We know the signs. A thin layer of iridium-rich clay found around the world, marking the impact that ended the age of dinosaurs. Microscopic spherules, melted glass droplets, formed in the heat of atmospheric re-entry, scattered across continents. Charcoal bands in sediment cores, evidence of wildfires that raged beyond control. And always after the fire, silence. The fossil record stutters. Biodiversity drops. Patterns break. Whole families of creatures vanish, leaving behind only empty space where lineage once flowed. But what if something more vanished, too? What if these fiery moments didn't just burn forests or floodplains, but burned stories? What if they erased civilizations? Not mythical ones, but real, fragile, early cultures, still climbing their way toward permanence, still learning how to inscribe thought into matter. Could a cosmic impact, like the Chicxulub event, have ended more than just species? Could it have erased voices? Could it have silenced memory? Volcanic winters can do this too. When the sky fills with ash, the sun dims, crops fail, climates shift, ecosystems collapse. In the wake of massive eruptions like Toba, like Tambora, famine spreads, populations dwindle, entire regions fall quiet, and sometimes they don't recover. Even now, we find gaps in oral traditions, sudden absences in archaeological sequences, empty layers where something should be, but isn't. We explain them as migration, drought, war. But what if sometimes the explanation is simpler? Fire came, and what it didn't burn, it buried. Not all loss is visible. Some is inhaled, like smoke. Some is felt, not in the body, but in the culture. Cut lines of ancestry, broken tools of language, forgotten songs. And what if these erasures happened deeper in time, before the written word, before preservation was possible? A small coastal civilization, perhaps, washed away in the tsunamis that follow an impact. Or an inland community buried beneath ashfall, their memories scattered by wind, their stories never fossilized, their maps never carved in stone. We might never know they were there, unless we find something strange. An anomaly, a layer of soot where none should be, a magnetic pulse in ancient rock, a scatter of isotopes that don't quite belong. And even then, we might not recognize what it means, because we are not trained to see memory where there is no monument. But Earth may remember differently, through chemistry, through disruption, through absence, and we may carry echoes too, in our myths, in our fears, in the persistent, recurring dream of fire from the sky, in the stories of floods and darkness and the sun disappearing. What if these tales are not pure invention? What if they are distorted memories, carried through generations, blurred by time, reshaped by need, but rooted in something real? What if the fire that came once or twice or more left more than soot? What if it left a scar in the human mind? And now we sense it, not as history, but as caution, as that deep, uneasy sense that the world can end quickly, that the sky can turn on us, that memory can be taken, not over centuries, but in a single day, a single blast, a single breath. And yet a fire is not only destruction, it is also transformation, clears the old. It makes space for the new. The forests return, the air clears, life comes back, but not the same, never quite the same. What was lost remains lost. What was burned does not rise in its original form. And so we live in a world shaped by forgotten fire, A world rebuilt again and again over the ash of previous versions. A world that remembers only in fragments, in the chemical residue of disaster, in the legends we can't trace, in the questions we're still learning how to ask. Could Earth have once held others like us? Dreamers, builders, thinkers, and could they have vanished not slowly, but suddenly? Not in decay, but in flame? And if so, what pieces of us are now at risk of being forgotten too? Maybe the ones closest to ice, because not all destruction comes with fire. Some comes with cold, with silence, with weight, with a soft, white patience that presses the world flat, then melts it back into motion again. We often think of glaciers as ancient and still, but they are anything but passive. Glaciers move, they grind, they shape, they erase, and then, when the world warms, they vanish. Suddenly, entirely, leaving behind only the emptiness they carved. Ice is not just a season, it's a force, and it has rewritten the surface of Earth many times. Entire regions have been scoured clean by ice sheets. Miles thick, heavy enough to crush mountains, persistent enough to flatten forests, slow enough to feel eternal. But glaciers are also editors. They don't just destroy, they choose. They leave behind hints, fragments, suspended boulders, smoothed valleys, submerged riverbeds. Not everything is gone, but everything is changed. And we wonder, what else has been buried? What else lies hidden under the melt? During the last ice age, sea levels were over 100 meters lower. Entire stretches of land now drowned were once exposed. Habitats, pathways, homes. Some believe the first migrations into the Americas came not through an open corridor, but along a coastal route now under the Pacific Ocean, erased by rising water and falling ice. And still deeper, older glaciers came before. During the Cryogenian period over 700 million years ago, Earth may have frozen nearly solid, a theory called snowball Earth. Glaciers reached the equator. The planet fell into a hush so deep, life itself nearly stopped. What could survive such a freeze? And what could possibly remain of what came before? Because when ice returns, it buries the world. Not gently, not kindly, but completely. And then, when it melts, the water doesn't apologize. It floods. It lifts the oceans. It redraws the coastlines. It fills the valleys carved by its parent ice. And in that flood, we lose something else. The chance to remember. What if there were archives on those vanished lands? Libraries, not of books, but of stone, of memory, of meaning. Cairns, structures, symbols. What if they now rest beneath silt and salt water, beyond where we've yet explored? We're only beginning to map the ocean floor at the resolution we need. We've explored less of Earth's seafloor than the surface of the moon. And the coastal shelves, the places most vulnerable to glacial melt, are among the most mysterious. Glaciers not only erase, they also seal. In places like Greenland and Antarctica, ancient air is trapped in ice cores. Tiny bubbles holding snapshots of prehistoric atmospheres, climates, eruptions. We drill down. We read the bubbles like time capsules. But these are the ice's stories. What about the stories it covered? Some caves beneath glaciers remain untouched for thousands of years. Some organic material survives in permafrost, perfectly preserved. Mammoths, seeds, bacteria. But what else sleeps there? Not just organisms, but evidence. What if something meaningful, something made, was swallowed by the advancing ice and never melted free? What if the cold holds forgotten chapters, pressed between layers of snowfall and time? And as the ice retreats, faster now than ever in human history, what might reemerge? Already, lost landscapes are appearing. Ancient forests, once flattened by glaciers, now rise again as peat bogs, exposing pollen from forgotten ecologies. Artifacts surface near retreating ice fields, tools, textiles, even human remains. Hints of people who lived near the edge of the cold, and were swallowed by it. And sometimes what melts out isn't just preserved. Sometimes it's warped, changed by pressure, compressed, broken into pieces too strange to immediately understand. And maybe that's why we've missed some of the oldest stories. Not because they weren't left for us, but because we didn't recognize them when they returned. If Earth has libraries, then glaciers are both their thieves and their protectors. They take without warning, and sometimes they give back. So we look to the ice, now vanishing across the globe, and we ask, what are we about to remember? What was once buried, and is now thawing into view? And what knowledge, pressed into silence by the weight of time, is finally ready to be heard again? And what if some of it never left? What if it was never buried, only unseen? We often imagine intelligence as something that builds, that leaves behind tools, machines, monuments, that sculpts the world into cities, that burns its name into stone. But what if that's only one kind of intelligence? What if something once walked here, something wise, something aware, and left no shadow, not because it disappeared, but because it chose not to leave a mark, or because it didn't need to? What, after all, is the shape of lost knowledge? We look for bones, for fire pits, for carvings, for patterns in artifacts that hint at understanding. We look for technologies, wheels, levers, code, energy. But intelligence may not always take that shape. It may not always build. Some creatures, even today, are deeply intelligent but do not change their environment. Whales, ravens, elephants, octopuses. They use memory, emotion, cooperation. They pass down learning, sometimes across generations. But they do not construct cities. They do not leave ruins. So what if an intelligence once rose before us, beside us, or somewhere entirely separate, that chose integration over invention, that blended into nature, that dissolved its knowledge into ritual, that passed meaning through gesture, through song, through forms not meant to last? Would we recognize it? Would we even know what to look for? We assume evidence has to endure. But maybe that's the flaw. Maybe wisdom does not always fossilize. Maybe the deepest insights were spoken into the wind and carried away. What if a civilization valued impermanence? What if it believed the truest things could not be held? No stone, no tool, no signal. Only living memory, carried in breath and body. And when those bodies returned to soil, the knowledge returned too. Would we call that primitive? Or would we realize we're the ones still learning how to let go? There's a quiet speculation that circles among archaeologists, linguists, and systems theorists, that not all intelligence scales toward complexity, that some plateaus, some refines, that some chooses stillness over expansion, harmony over dominance, presence over permanence. What would that evidence look like? A footprint in moss? A stone turned intentionally, not for function, but for feeling? A pattern of growth in a forest, designed over centuries, invisible unless seen from the sky? A migration path aligned with stars we no longer recognize? The problem is not absence. The problem is recognition. We're trained to find what we expect. We find tools because we understand tools. We find ruins because we build them too. But what if the shape of intelligence, in some distant past, looked more like a gesture than a monument? More like a balance than a blueprint? A language of rivers, an ethic of silence, a life that saw permanence not as power but as burden. And so it stepped lightly, and so it left no shadow. Maybe we've walked across these places. Maybe we've studied them, measured them, mapped them, and never known what we were looking at, because we assumed intelligence must be loud. But what if it was quiet? What if the first civilizations did not conquer, but cooperated? What if they weren't forgotten but never recorded by their own choice? We tend to think knowledge must be externalized, written, built, stored. But in many traditions, ancient and living knowledge is carried, held in memory, sung in cycles, shared through ceremony, not codex. And when those lineages break, the knowledge dissolves. Not because it was wrong, but because it was living. And living knowledge cannot fossilize. So perhaps the shape of lost knowledge is not an artifact at all. Perhaps it's a gap, an absence where something should be but isn't, a silence in the data, a question that refuses to resolve. We call these anomalies. We call them myths. We call them mysteries. But maybe they're messages, not written to last, but to be rediscovered when we're finally ready to understand them. So we must learn to listen differently, to look not only for the sharp edges of invention, but for the soft patterns of intention. To ask, what kind of wisdom leaves no evidence at all? And to wonder if we're surrounded by it still, unmeasured, unnoticed, but waiting. And if such a civilization once walked here, quietly, long ago, perhaps it never truly left. Perhaps it simply stepped aside and trusted the earth to carry its memory forward. In silence, in rhythm, in the things we call mystery. But what if the earth hasn't just carried memory? What if the earth is memory? What if it is not just ground and gravity, but something more, something whole, something aware, not in the way we are, but in the way a forest is, in the way a dream is? What if we are not the first dreamers, but part of a much older, deeper dream? Planetary dream, sprawling, slow, recursive, unfolding in epochs, not hours. The idea sounds strange at first. Earth as a mind, earth as a presence, but not one that speaks in words or symbols. One that speaks in emergence, in storms, in species, in symmetry, in time. It may not think the way we do, but it becomes. And in becoming, it may be dreaming. Every part of the earth behaves like part of a mind. Its rivers remember their paths. Its mountains resist. Its atmosphere responds. Its crust stores. Its ecosystems self-correct. Its climates shift, not randomly, but in long, thoughtful pulses, as if something is being balanced beneath the surface, again and again. We've seen it in the Gaia hypothesis, the proposal that Earth functions as a single, self-regulating organism. That life, land, air, and ocean don't evolve in isolation, but together, maintaining conditions that support the whole. To some, this is just a metaphor. To others, it may be more. Because if Earth behaves like a body, what prevents it from also having a mind? Not a personality, not a will, but a kind of awareness, a field of intelligence expressed through emergence, not intention. Some neuroscientists now explore panpsychism, the idea that consciousness may not emerge from complexity, but may be a fundamental quality of reality. That all matter, even the smallest particle, contains a flicker of experience. If that's true, then Earth, layered, flowing, ancient, might contain a richness of experience far beyond our own. It may not speak, but it may dream, and perhaps we, humans, animals, forests, fungi, are not separate from that dream. We are its contents, its questions, its way of reflecting back on itself. We may be Earth becoming aware of Earth. Not metaphorically, literally. Our brains made of the same minerals as mountains. Our blood echoing the salinity of ancient seas. Our thoughts sparked by electricity, just as lightning splits sky, just as magma stirs under tectonic breath. And what is a dream if not memory in motion? Stone remembers, slowly. Oceans remember chemically. Genes remember biologically. And perhaps we remember emotionally the things the earth cannot store in rocks. Perhaps we are here to feel what the continents forget, to grieve extinction, to wonder at stars, to ache for the presence of things we cannot name. Maybe this is the role of the dreamer, to feel on behalf of the whole, to carry questions too delicate for stone, and too quiet for time. Could that be why we ask these things? Why we look at fossils and isotopes and lost coastlines with a sense of longing, not just curiosity? Why we listen to caves and stars and deep ocean silence as if they're on the verge of remembering something? Maybe it's because Earth is remembering through us. Not because we are separate, but because we are part of the process. The dream dreaming itself. And like any dream, it loops. It dissolves. It leaves traces. A broken pattern in basalt. A half-remembered glyph. A rhythm in migration. A feeling that we've seen this before. Maybe we have. Maybe the planet is trying something again. Maybe every era is not a new page, but a new interpretation. And if the Earth is dreaming, what are we to that dream? A whisper? A question? A hope? We are made of its dust, its water, its fire. We are it in a fleeting arrangement of consciousness. We rise, we reflect, we vanish. But maybe something remains. Not the body, not the name, but the signal, the feeling, the echo. And maybe the earth listens to those echoes the way we listen to dreams we forget by morning, but still carry through the day. Softly, half aware, but moved. And so we live not on the earth but within it, as sparks, as threads, as sentences in a book still being written, line by shifting line, in roots and rain and time. And if we are part of a planetary mind, dreaming itself forward, what might it dream of next? Perhaps that we begin to listen, not with instruments alone, not with equations or drills or maps, but with presence, with stillness, with the kind of attention that asks nothing, but waits, because beneath the language of science, beneath the measurements and models and tools, there is something older, something simpler. Science at its root is not about control. It is about listening. And the earth has been speaking all along, not in words, not in noise, but in layers, each one a page, each one a whisper, each one a question not yet answered, but asked again and again through stone, salt, ice, and time. We listen through the crust, through fault lines, through the slow grinding of plates. Every earthquake is a syllable, every uplift a sentence, every fold in the rock a quiet story told under pressure. We listen through the ocean floor, where ancient sediments settle in bands, chemical, mineral, organic, building quiet archives of forgotten climates. We listen through isotope ratios, where oxygen and carbon and nitrogen carry the signatures of life and death, of warmth and cold, of balance lost and found again. These are not just numbers. They are rhythms, echoes, traces of what the planet has endured, and what it might still remember. We listen through ice, two clear cores pulled from Antarctica and Greenland, each one a column of breath, a record of snowfall and fire, of pollen and pollution, of sudden shifts and long stillness. Each bubble of ancient air holds a version of the sky we never breathed. And yet, it shaped us, and now we breathe in return. Even the coastlines speak when we learn how to hear them. Drowned riverbeds etched beneath the sea. Coral terraces that rise like forgotten stairways. Salt marshes migrating inland, century by quiet century. They tell us where the ocean has been, where it may go again, and who lived at its edge before the waves returned. But this kind of listening is slow. It doesn't shout. It hums. And we are only beginning to tune in, because listening to the earth requires more than tools. It requires humility, the willingness to sit with uncertainty, to follow a pattern without rushing to name it, to let a silence remain a silence, without trying to fill it. What if the earth's oldest questions are not mysteries to be solved, but invitations to be heard? What if science is not the act of solving the world, but being in relationship with it? To listen to the layers is to accept that some pages are torn, that some voices are missing, that some chapters have been folded beneath others. And still, the story continues, because the earth keeps speaking, in erosion, in eruption, in extinction, in recovery, in resilience, in recurrence. It speaks when the rivers change course, when the glaciers sigh, when the desert blooms. Even now, deep listening is revealing things we never knew to ask. We're finding microfossils where we thought life couldn't survive. We're discovering isotopic shifts that point to ancient events with no clear cause. We're watching magnetic fields wobble, forests pulse, coastlines drift, all in patterns older than history. And through it all, a quiet invitation. Are you still listening? Because Earth has not stopped asking its questions. It asks them in fault lines and fire, in dust and data, in the way a trilobite turns to stone, in the way a coral remembers temperature in its growth rings, in the way ice holds onto the memory of a volcanic sky. These are not accidents. They are records, held not for us, perhaps, but shared with us now because we're ready, because we are beginning to hear not just events, but relationships. Not just results, but rhythms. Not just facts, but echoes. And maybe, just maybe, the role of science is not to answer the earth, but to ask better questions. To lean closer. To let the noise fall away until all that's left is that hum, that pulse, that slow awareness beneath everything. And so we listen. Through the layers. Through the years. Through the tremble in the core and the drift of the stars and the bones beneath the soil. Not to conquer, but to remember that Earth is not just a place we stand. It is a conversation we are born into, and what we hear depends on how deeply we are willing to listen. Could the Earth be older than we think? It's a question we began with, and now we return to it not with a conclusion but with a deeper silence. Not because we found the answer, but because we learned how to live inside the question. We measure Earth's age as 4.54 billion years, a number built from isotope decay, from uranium clocks, from zircon crystals older than continents. It is a precise number, a trusted number, but is it the whole story, or just the part we know how to measure? We've walked now through forgotten coastlines, drowned caves, magnetic reversals, and firestorms. We've touched deep time not as a timeline, but as a spiral, as a memory, as something folded. And in that folding something shifts. Not the facts, but the feeling. What if Earth has held more than one beginning? Not one spark, but many? Not a single timeline, but cycles. Stacked, erased, reborn? What if time, our time, is not the first? What if the Earth was old before age began? It's hard to say what that means. Harder still to measure it. Because measurement depends on memory, on continuity, on evidence that survived. But as we've seen, so much doesn't survive. So much vanishes not because it was weak, but because it was too early, too soft, too subtle, too easily undone by water, wind, fire, or ice. Entire epochs might have come and gone, and left no fossil, no ruin, no trace we'd recognize. That doesn't mean they didn't happen. It just means they aren't here anymore. And so we sit now at the edge of knowing. A place where science becomes philosophy, where geology touches poetry, where the difference between 4 billion and forever begins to dissolve. Because maybe what we're really asking isn't, how old is the Earth? Maybe we're asking, how much has Earth lived? And could it be more than we know? More than we've dreamed? More than we're ready to understand? There's a kind of reverence in that not knowing, a kind of spaciousness, a pause. The kind of pause we feel when we walk into an ancient forest and sense something beyond language. When we stand by the ocean and realize it has forgotten more than we'll ever learn. When we hold a rock that predates the moon and feel the weight of unrecorded time. It's not emptiness, it's presence. And we are part of it. Flickering, fragile, momentary, but here. Perhaps Earth is not asking us to solve it. Perhaps it is asking us to accompany it. To witness. To wonder, to imagine not only what was, but what might have been, and to let that imagining soften the way we see ourselves, not as the peak of history, but as a single layer, a single breath, a single story among stories we may never find. And still, they shape us. Even in their absence, they shape us, because wonder shapes us, and mystery humbles us, and perhaps that is the oldest wisdom of all. The one that remains, even when memory fades, that it is not knowing which gives us meaning, but the desire to understand, to walk gently in places where names have been lost, to hold questions like fossils, precious, incomplete, beautiful, to be willing to listen, even when the echo never comes. Could Earth be older than we think? Yes, maybe not in years, but in possibility, in depth. In the unfathomable complexity of lives and layers, of rises and resets, of time that loops and spirals and waits. Maybe the Earth is not older than we think. Maybe we are simply newer than we realize. Maybe we are the most recent voice in a long chorus. Maybe we are singing a song that began before language. And maybe that song continues after us, whether we hear it or not. So we return to the question, not to close it, but to carry it forward. Could Earth be older than we think? Could life have come and gone before? Could memory have slipped through stone? Could silence be a kind of evidence? Could we be standing, even now, on stories we'll never know? Yes. And maybe that's the point. Thank you for dreaming with us tonight on the planet's memory. If you felt something stir in you during this journey, an ache, a question, a small and ancient wonder, consider leaving a like, a comment, or sharing this with someone who loves quiet mysteries. And until next time, remember, not everything lost is gone. Some things are simply waiting to be remembered. Good night.